We just found the biggest clue ever that someone lived on Mars. Or should I say, something. Because if you're picturing skinny red extraterrestrials with big goofy eyes, forget it. The Martians we're talking about looked more like this, a tiny microbe. I know, a total bummer, but this could change everything. See that weird pattern on the rock? The one that looks like leopard spots? Experts think it was left behind by ancient life. And no, it's not like someone painted it, the way early humans drew on cave walls. These little marks could actually be leftovers from microbes, signs that some pretty wild chemical reactions were happening back when they were formed. And don't worry, we'll get to that in just a second. So NASA actually found this evidence over a year ago, and they were thrilled, as this was exactly the kind of weird rock they'd been hoping to see on Mars. They thought this weird pattern might be a biosignature. In other words, a clue that life was once there. That could mean an element, a molecule, some substance, or in this case, a funky leopard print pattern on a rock. But scientists were cautious back then. After all, you can't just go around shouting, "We found life on Mars," without being absolutely sure. It could have just been, well, a cool-looking Martian rock, right? So, they studied this sample again and again. And by they, I mean more than 1,000 scientists from NASA and partner institutions all over the world. And recently, they finally came out with a paper that basically says, listen, we can't find another explanation. And that's it. With no other explanation left, this might just be the best evidence we've ever had that something really did live on Mars. The sample, nicknamed Sapphire Canyon, was collected by the Perseverance rover in July 2024. It was taken from rocky cliffs along the edges of the Neretva Vallis River Valley, a region shaped long ago by water that once flowed into Jezero Crater. And we're talking like more than 3 billion years ago. Scientists believe that back then, Neretva Vallis was filled with rushing rivers carrying mud, sand, and gravel into the lake. When the water eventually dried up, it left behind the rocky outcrop where Sapphire Canyon was found. After collecting the sample, the Perseverance rover kept exploring the river valley to get a better idea of the environment where those rocks formed, and to figure out how those leopard spots might have appeared. That step matters because knowing exactly how the spots came to be is key to figuring out if the rock really holds signs of life. In other words, did those patterns form through normal chemical processes that don't need life at all? Or were they actually left behind by microbes? What the rover's instruments found is that the rocks in this area are made of clay and silt, which is exciting. Because here on Earth, those materials are great at preserving signs of ancient microbial life. The rocks are also packed with organic carbon, sulfur, oxidized iron, and phosphorus. And you know who loves that stuff? Microbes. Experts think they could have used those ingredients as an energy source, and in the process, left behind the leopard spots we can now see in high-resolution images. Remember when I said these marks might be a microbe's leftovers, right? That's exactly it. Picture you're eating a burger called the Galaxy Burger that has a one-of-a-kind sauce. A drop of that sauce falls on the table. You don't clean it up, and a second later, poof, you disappear. Later, detectives show up trying to figure out if you were there. All they find is that sauce drop you left over. From that, they can tell exactly what you were eating. The Galaxy Burger. But proving you were really there is tricky, since that sauce could have ended up there in lots of other ways. The same goes for the leopard spots. Just by looking at them, scientists can already tell a few things. For example, the pattern shows the presence of 2 iron-rich minerals, vivianite and greigite. On Earth, vivianite often turns up in sediments near decaying organic matter, or in swampy, soggy wetlands. In a similar way, microbes can also produce greigite on our planet. When you find those two together, it looks like they formed through electron transfer reactions between the sediment and organic matter. that could be a fingerprint of microbial life, because microbes use those reactions to get energy and grow. So, going back to our burger comparison, the leopard spots are like the sauce on the table, the leftovers from the process of getting energy. But that's not the only theory. The team also spotted the possible presence of hematite in the rock. And if Mars has the nickname the Red Planet, hematite is the one to blame. It's a heavy mineral that can take on a reddish tone. On Earth, people have been using it as a pigment for paint for thousands of years. Now, scientists think the leopard spots may have formed when chemical reactions with hematite turned parts of the rock from red to white. That process can release iron and phosphate and possibly cause those black rings to appear. And here's the kicker. Those reactions can also provide an energy source for microbes. For now, though, these are just theories. What we can confirm is that those chemical compounds are definitely present in the rocks. But just like in the detective story, finding the sauce drop doesn't prove it came from you. So even though these materials are great for microbes to thrive on, it doesn't automatically mean this is a biosignature. They could have also formed abiotically, or, put simply, without the presence of life. Yeah, it could happen, but for it to happen naturally, without microbes involved, you'd need two things: high temperatures and acidic conditions. That's the only way those chemical processes could do their magic and leave behind the leopard spots. And here's the exciting part. Scientists didn't find any sign that these Martian rocks were ever exposed to high heat or acidic conditions. That's why I said they're stumped. They just can't find another explanation. So this has to be a biosignature, right? Well, maybe not. Because there's still a possibility that organic compounds could react even under low temperatures. And maybe, just maybe, we're seeing that happening for the very first time. That's why it's so hard to confirm 100% whether this is the handiwork of ancient microbes or just a natural process. So, in the end, we're still left with more questions than answers. Right now, this precious sample is safely sealed inside a tube millions of miles away on Mars. Hopefully, one day, it'll be brought back to Earth so scientists can study it in labs here. And while we can't confirm it's a biosignature just yet, one thing is certain. This finding by Perseverance is the closest we've ever come to discovering life on Mars. Honestly, just being able to spot a potential biosignature on the Red Planet is already groundbreaking. Another reason this finding matters has to do with the age of the rock. This evidence comes from some of the youngest sedimentary rocks we've ever studied. Until now, scientists thought that if we ever found signs of ancient life on Mars, they'd most likely be locked inside much older rocks. But so far, nothing has shown up in those ancient formations. Finding a possible biosignature in a young rock suggests two things. First, Mars might have been habitable for longer or later in its history than we ever thought. And second, older rocks might also hold signs of life, but maybe they're just harder to spot. Someday, our technology could be advanced enough to find them. This discovery also makes us think about one of the biggest questions of all, and that is, are we truly alone in the universe, or did we just find the answer? No, not exactly, but it's the closest humanity has ever come to answering that question.
What if Martians came to our planet? What if a Mars rover brought back some unknown organism that began to reproduce and wipe out all life on Earth? Well, we've seen this scenario hundreds of times in movies and read about it in books. But in reality, the situation is the opposite. We are the threat. Humans are the ones that could infect another planet. We are the ones that could become the destroyers of Mars. And to prevent that from happening, countries created an international agreement that forbids us from taking certain actions on our red neighbor in space. It sounds like science fiction, but it's real. This agreement is called the Outer Space Treaty. It was signed in 1967 by the Soviet Union, the United States, and the United Kingdom. The treaty states that no country that signs it can claim sovereignty over any celestial body. It also contains many other important rules, but one of them directly addresses how we should search for extraterrestrial life. Now, there's a possibility that certain regions on Mars could potentially host life. However, according to the Outer Space Treaty, exploring these so-called special regions is prohibited. That sounds strange, doesn't it? Searching for life on Mars is one of the main goals of the entire space industry. So, how can these areas be off-limits? Well, the reason is contamination. When we explore these regions, we might accidentally bring life there. A tiny but extremely resilient microbe or bacterium could hitch a ride on a spacecraft, land on Mars, and begin to reproduce. But scientists are not only afraid that Earth's bacteria will destroy Martian life, there's a possibility that these two types of bacteria will mix, and we will not be able to separate one from the other. But what if it occurs that these bacteria were originally from Earth? Imagine NASA spending billions of dollars collecting samples of Martian soil, where life has been detected. The spacecraft brings these samples back to Earth. Scientists analyze them and suddenly realize that these Martian bacteria are actually ours. They had arrived on Mars 10 years earlier, when a robotic rover was simply taking pictures of the Martian landscape. Here on Earth, we already know bacteria that can survive extreme pressure, incredibly low and high temperatures, and even the complete absence of oxygen. For such organisms, adapting to Mars conditions might not be that difficult. But what if they change in that environment? What if they mutate and take on new forms? Scientists might believe they've discovered true alien life, when in reality, it's just Earth microbes that evolved on Mars. There's also a chance that Martian microorganisms could mix with Earth bacteria, making it impossible to separate them. In short, exploring places where life might exist could create massive scientific confusion. And what if contaminating Mars with Earth's life causes it to spread rapidly? What forms would that life take under conditions completely different from Earth's? Mars and the Moon can be explored, but it must be done with extreme caution to avoid biological pollution. And don't worry, the Outer Space Treaty also requires us to be careful not to bring potentially harmful Martian life back to Earth. So, what exactly are these special regions on Mars? Well, they're places where conditions might allow microorganisms to survive, which are warm and wet spots. But here's the ironic part. We currently don't know locations on Mars that meet these criteria. But if there are such places, we can't reach them. So in practice, this law about special regions hasn't really been tested yet. However, scientists also talk about uncertain regions. These are areas that could potentially be classified as special regions after further study. One example is recurring slope lineae, or RSL. These are dark, narrow streaks that appear seasonally on Martian slopes. At first, scientists believed these streaks were signs of liquid water. Later studies showed that RSL are formed by dry granular flows. So, does that mean there's no chance of finding life on Mars anytime soon? Perhaps. But what about all those headlines claiming that water was found on Mars? Couldn't that mean life exists there? Yes, scientists have discovered water, and it's not just small amounts, but entire oceans. The problem is that this water is buried 7 to 12 miles beneath the Martian surface. For comparison, the deepest hole ever drilled on Earth, the Kola Super Deep Borehole, is about 7.5 miles deep. We couldn't drill deeper on our own planet. Now imagine how much time, money, energy, and technology would be required to make a giant pit on Mars. For now, such a mission sounds more like sci-fi than reality. But let's say we do find a microbe on Mars and bring it back to Earth. What kind of danger could such a tiny organism pose? Well, science fiction thrillers give us dramatic answers, but there's also a real-world example. Take the fungus known as chytrid. This microscopic organism reduced populations of frogs, salamanders, and other amphibians across the globe. and this biological disaster affected humans as well. Chytrid is not an alien organism, but its story perfectly illustrates what can happen after even a small biological contamination. When chytrid infects a frog, it causes a severe disease. The fungus attacks the animal's skin, disrupting its ability to regulate water and electrolytes. Electrolytes are salts and minerals essential for biological functions. When this system breaks, it leads to heart failure. The frog doesn't survive, and the fungus continues to multiply and infect other creatures. The outbreak was first detected in northwestern Costa Rica in the early 1980s. From there, it spread south and east, reaching Panama in the 2000s. More recent research suggests that chytrid originated in East Asia and spread worldwide through the pet trade. How it evolved the ability to devastate amphibians is a story for another video. For now, let's focus on the consequences that still affect us even today. Over several decades, the chytrid epidemic caused massive declines in amphibian populations worldwide. Around 90 species disappeared entirely. The impact was especially severe in Costa Rica and Panama. As amphibian numbers dropped, so did the populations of predators that fed on frogs and salamanders. But that wasn't the main problem. Remember what frogs like to eat. They catch mosquitoes and various bugs. So after the fungus pandemic, the insect population increased dramatically. Now think about what is dangerous about mosquitoes. Yes, they bite and leave an itchy mark on your skin, but some species carry dangerous infections, such as malaria. As frog populations decreased, malaria cases among humans increased. Studies showed that infection rates began rising about a year after amphibian decline started. Over the next 3 years, the number of malaria cases rose, but then stabilized. About 8 years after the chytrid outbreak began, malaria rates started to decline and eventually returned to previous levels. Does that mean frog populations recovered? Unfortunately, no. Amphibians are still struggling. It's possible that humans simply took stronger preventative measures against malaria, or perhaps other animals began feeding on mosquitoes. Either way, the ecosystem never fully returned to its original balance. This is the core problem with biological contamination. Damaging one species disrupts an entire system. Like a chain reaction, problems spread from one link to the next. If a simple fungus managed to affect life on Earth where humans can fight epidemics, imagine what a microbe could do on Mars. Even if life exists there, a single Earth organism could wipe it out completely. The reverse is also true. A Martian microbe could cause serious problems on Earth. Imagine a spacecraft returning from Mars and landing in the ocean. A Martian microbe jumps into the water and attaches itself to a shark. The shark begins to change into something terrifying and starts attacking other sea creatures. Fish become more aggressive and begin attacking anything that moves in the water. Mars's bacteria is multiplying. The fish becomes unsuitable for food. Fishing industry suffers losses, and many people begin to experience hunger without fish. Marine mammals disappear, and things get worse and worse. Okay, let's not be so dramatic, but you get the idea. Now it seems there's new solid evidence that Mars once had rainforests, real rainfall, and long-lasting rivers. NASA's Perseverance rover found a mineral called kaolinite on the floor of Jezero crater. Down on Earth, this stuff only forms in warm, wet places with heavy rain that lasts for millions of years. And this kind of rain feeds jungles, not deserts. That means Mars had showers for a long time. And that changes everything we thought we knew about the planet. So that mysterious kaolinite doesn't form from a quick flood or a melting glacier. It forms when liquid water keeps soaking into rock over insanely long periods, breaking it down grain by grain. When Perseverance spotted kaolinite pebbles and boulders scattered across Mars, scientists realized Mars once behaved less like Antarctica and more like the Amazon. That tells us that ancient Mars had a stable climate, thick enough for atmosphere, and a functioning water cycle with clouds, rain, and runoff. The place where the kaolinite showed up, Jezero Crater, is pretty cool itself. It used to be a massive lake, fed by rivers that carved channels you can still see today from orbit. Scientists think those rivers could have washed the kaolinite into the crater like a conveyor belt of rainforest soil. Another theory is that a meteor impact blasted the material out of nearby terrain and dropped it there like cosmic shrapnel. Either way, water clearly moved these rocks around, and moving water is a huge deal because stagnant water doesn't shape landscapes like that. Every form of life we know depends on liquid water. Not ice, not vapor, liquid water that sticks around. A warm, wet Mars with rainfall would have had streams, wetlands, and chemical reactions happening non-stop, which are the same ingredients Earth used to kickstart life. Now, this doesn't mean Mars definitely had some creatures waving at the sky, but the planet checked way more boxes for habitability than we ever expected it to. For decades, Mars looked like a planet that maybe thawed for 5 minutes and then froze forever. Now it looks more like a world that stayed comfortable for hundreds of millions of years before everything went wrong. Scientists think Mars lost its atmosphere because it lacked a strong magnetic field, which is like a shield that protects planets from the solar wind, a constant blast of charged particles from the sun that can strip a planet bare over time. While all that rainforest talk grabs headlines, Mars keeps stacking surprises. In 2025, scientists spotted skylights on Mars. Those are giant holes in the surface of the red planet that drop straight down into underground cave systems, which formed long ago. On Earth, caves like this protect life from radiation, temperature swings, and surface chaos, which makes them perfect hiding spots if ancient Martian life ever existed. Some of these caves might be karstic, which means slightly acidic water slowly dissolved the rock, carving out underground chambers over time. That process needs liquid water and patience, which Mars apparently had plenty of back in the day. Scientists suspect these caves could trap ice, preserve chemical fingerprints of life, or even lock away organic material untouched for billions of years, like a time capsule no one has opened yet. The caves sit in a region called Hebrus Vallis, tucked between an old volcano and a massive plain in Mars's northern half. This area doesn't show signs of lava tubes, which scientists already know exist on Mars. Instead, it shows ancient river channels, hydrated minerals, and sediments that only form when water sticks around. Scientists spotted 8 skylights and knew they weren't impact craters because nothing splashed outward when they formed. The surface simply collapsed into empty space below. Researchers pulled this story together using old Mars mission data, including mineral maps, hydrogen readings that hinted at buried water, and ultra-sharp images from orbit. The big deal is this: caves protect things. They block radiation, trap ice, and preserve chemical traces far better than the surface ever could. If Mars ever hosted life, even tiny microbes, those caves rank among the best places to find what's left. Now, a year earlier, in July 2024, the Perseverance rover drove along what used to be a river billions of years old. After the river dried up, part of a rock face broke loose and fell into the channel. Perseverance found it sitting there, untouched for ages. Scientists named it Sheyava Falls. The rock's surface showed tiny dark spots scientists nicknamed poppy seeds, and larger pale blobs with dark rims called leopard spots. When Perseverance zoomed in, it also detected organic molecules. These are carbon-based compounds, the same basic ingredient every living thing on Earth uses. Scientists predicted years ago that if Mars ever hosted microbes, rocks like this one would exist. These spots matter because life needs energy. Some organisms use sunlight, others eat chemistry. Microbes can survive by moving electrons between chemicals, kind of like stealing spare batteries to power themselves. At Sheyava Falls, scientists think microbes could have taken electrons from organic compounds and handed them to iron in the rock. That reaction releases energy that microbes can use to survive. So, Sherlock, the evidence lines up. The dark dots and rims contain a mineral called vivinite, which only forms when iron gains electrons. When iron changes this way, it loses its rusty red color and turns pale. That explains why the centers of the leopard spots look lighter. Perseverance also found another mineral there called greigite. Greigite needs sulfide to form, and microbes can create sulfide by feeding electrons to sulfate, another chemical found in the rock. Now, scientists can't fully analyze this rock yet, but they already have one tool down on Earth, the kind so small you'd miss them unless you knew exactly how to look. If microbes ever lived in Mars's ancient oceans, they probably didn't leave skeletons or bones. They left chemical fingerprints locked inside minerals. On Earth, microbes showed up in oceans about 3.7 billion years ago, give or take. Mars had water around the same time. When water evaporates, it leaves minerals behind, and some of those minerals can trap microorganisms like bugs and amber. On Mars, scientists expect sulfate minerals to play that role. On Earth, gypsum does the same thing. To test this idea, researchers went to a gypsum quarry in Algeria. Millions of years ago, the Mediterranean Sea almost dried up and left thick gypsum layers behind. Those layers preserved ancient bacteria inside them. All this makes the site a perfect Mars stand-in. The team tested a compact device called LIMS, which is an easier way of saying laser ablation ionization mass spectrometer, which I'm only going to say once. A laser zaps a tiny spot on a rock, vaporizes it, and then reads the chemical elements released. Each element leaves a unique signal, like a barcode. That lets scientists spot chemical traces linked to life. When they aimed LIMS at the Algerian gypsum, scientists found thin, thread-like structures already known to be bacteria. They also spotted minerals that microbes help create, like dolomite and certain clays. That matters because microbes don't just leave fossils, they change rocks while they live. Mars makes this harder, though. Its environment differs from Earth's, and any fossils there would be billions of years old, not millions. Scientists also need to rule out non-living processes that could copy these signals. Now, lots of people think that to find all the answers, humans must go to Mars. And the number one goal for the first human mission to Mars is finding life, not digging up resources or setting flags. Scientists want to know if Mars ever hosted living organisms, if it still does today, or if the planet once ran the chemical experiments that led to life. After that, researchers want to understand where Mars keeps its water and carbon dioxide, how those cycles work, and how they changed over time. Geology comes next because rocks keep the planet's memory. Every layer tells part of Mars' story. Scientists need to understand how Mars affects the human body, the brain, and even group dynamics when people live together in isolation. Long-term plans go even farther. Scientists want to learn how plants, microbes, and animals survive on Mars, how radiation alters DNA, and whether reproduction works across generations. They also want to know if Martian microbes could harm astronauts or equipment.
There's a huge hole on Mars, more than 300 feet wide, and it seems that NASA agrees that it could be an opening into an underground world. Could a mysterious space civilization be hiding in there? Well, experts from NASA think that the hole might lead to a lower layer under the surface of the red planet. You can think of it like a trapdoor that opens into a basement. Scientists care a lot about holes like this because they might connect to big underground caves. These caves would be hidden from the surface and could be safer places for life to exist. You see, Mars' surface is a rough place. It's freezing cold, extremely dry, and constantly hit by radiation. Meanwhile, underground spaces are different. They're like natural shelters, protecting anything inside. That's what makes them some of the best places to look for signs of life on Mars. Interestingly, NASA is usually very careful when talking about life on other planets. Until now, most researchers have been focusing on tiny life forms like microbes, which might be hiding in frozen oceans on nearby planets and moons. But now, scientists really think this hole could lead to huge underground caves. If that's true, besides looking for signs of life, this spot could become a target for future astronauts, since the caves could turn into great shelters and even a Martian base. The photo with the hole isn't new. It was taken in 2017 by the Mars Reconnaissance Orbiter. In the image, we can see many holes scattered across the ground. The area basically looks like Swiss cheese. Most of the holes have dark, dusty ground under a thin layer of light-colored frozen carbon dioxide, aka dry ice. But one hole stands out from the rest. It's perfectly round, sits in the upper part of the image, and is about 328 feet wide. That's a massive opening. The hole also has a perfectly round crater around it. It's like something punched through the surface and left a ring behind. Scientists think it may have been caused by a meteor impact. Scientists believe Mars was much more like Earth billions of years ago, with better conditions for life. But today, the best chance of finding signs of life is underground. Mars no longer has a strong magnetic field or a thick atmosphere, so its surface is constantly blasted by harmful radiation from space. Underground caves or lava tubes act like natural bunkers, shielding anything inside from that radiation. This makes them the most promising places to search for life. Because of that protection, astronauts might one day find signs of past life there, or even fossils. To hunt for these hidden spaces, NASA brought in experts on underground structures and seismic activity from the U.S. Geological Survey. In 2019, they released a detailed map showing more than 1,000 possible cave entrances scattered all over Mars. There's a catch though. All of this data comes from spacecraft flying about 250 miles above the Martian surface. From that height, scientists can spot holes, but they can't see how deep they go or what's underneath. Some may be true caves, while others could just be shallow dents in the rock. Other missions, including the European Space Agency's Mars Express, have also found signs of ancient lava tubes beneath Mars's long-extinct volcanoes. But what makes this newly released image stand out is that it clearly shows at least one hole that appears to lead into an unknown underground layer. And if current plans come true, the earliest human astronauts could see this massive opening with their own eyes in the 2030s. And maybe they'll also be able to examine another Martian mystery. For more than 50 years, scientists have been puzzled by about 2 million dark streaks spread across the surface of Mars. These black marks look like long stains or shadows running downhill. It's almost like someone spilled ink on the planet. They were first spotted in the 1970s, and for decades, no one could explain what caused them. These marks are called slope streaks. They appear on steep slopes, crater walls, and ridges all over Mars. From far away, they look flat and dark. At first, scientists thought the streaks were caused by melting ice. This could create muddy landslides similar to wet dirt sliding down a hill on Earth. Even today, researchers still believe the streaks come from landslides, but not the kind involving water. New research using data from NASA's Mars Reconnaissance Orbiter shows that most of these streaks are caused by dry landslides. Instead of mud or water, it's loose dust suddenly slipping downhill, more like dry sand pouring off a pile when it gets disturbed. This explains how the streaks can form in Mars's cold, dry environment. One famous example is on Apollinaris Mons. It's an extinct volcano south of Mars's equator. On one side of a ridge, hundreds of streaks run side by side, which makes the surface look like a barcode. These streaks appeared sometime between 2013 and 2017. Scientists figured out a bit later that a nearby meteoroid impact could have triggered them. The impact didn't hit the ridge directly, but the shock shook the ground, and it was enough to send dust downhill. Now, because some streaks appeared after impacts, many scientists thought that meteoroids or Mars quakes were responsible for creating most slope streaks. But a new study shows that this idea is kinda wrong. The study in question looked at about 2.1 million slope streaks. They were photographed by NASA's Mars Reconnaissance Orbiter over a long period, from 2006 to 2024. Scientists have estimated that Mars has around 1.6 million slope streaks in total. But some streaks have been counted more than once because they appear in different image sets. So, after analyzing all this data, researchers have concluded that almost all new streaks form because of wind and dust, not impacts or quakes. Look, seasons change on Mars and winds slowly move dust and sand. When that loose material suddenly slips downhill, it leaves behind a dark streak. It's like brushing dust off a surface and revealing a darker layer underneath. Meteoroid impacts and Marsquakes do create some streaks too, but only in very specific spots. Overall, they play a very small role. Less than 0.1% of new slope streaks are caused by impacts and Marsquakes. The analysis has also shown that slope streaks are not spread evenly across Mars. They're grouped into 5 main regions. In each of these areas, new streaks usually form during times of the year when winds are strongest. There's a key tipping point called the dust movement threshold. Once winds get strong enough to lift and move dust, the loose material on slopes becomes unstable. When that happens, dust can suddenly slide downhill, creating a dark streak. This is similar to how strong winds on Mars can kick up dust and form spinning columns called dust devils. They're like small tornadoes moving across the planet's flat plains. One reason this mystery took so long to solve is that these streaks form when scientists can't easily see them happen. The conditions that create new streaks usually occur around sunrise and sunset. And because this phenomenon happens in low light, no spacecraft has directly watched a streak form in real time. The study also calculated how often new streaks appear. On average, about 0.5 new streaks form each year for every existing streak. And since Mars has around 1.6 million slope streaks, that's roughly 80,000 new streaks forming every year. Most streaks seem to stick around for several decades before they slowly fade away. However, scientists don't yet have enough long-term data to be completely sure. Another cool discovery: even though slope streaks cover less than 0.1% of Mars's surface, they may be one of the biggest sources of dust in the Martian atmosphere. In other words, these small-looking features may play a much larger role than we expected. That's why understanding how slope streaks move dust around Mars is important. Mars's dust affects weather, visibility, and even how much sunlight reaches the ground. That matters a lot for future human colonies, which would need stable conditions to survive and operate safely.
Uh-oh. Something is nearing the surface of the planet. It looks like a fireball hurtling closer and closer at a truly incredible speed. Soon, it becomes obvious that the collision is inevitable. Bam! The impact leaves a huge crater. It evaporates thousands of cubic miles of solid rock, and it also sets off a series of terrible natural disasters. I know what you're thinking. You believe I'm talking about the catastrophic collision that occurred around 66 million years ago on Earth. You know, the one that's responsible for the extinction of non-avian dinosaurs and 3/4 of other life forms on our planet? But no, the disaster I'm talking about happened on a different planet. Scientists think that our close neighbor, Mars, once experienced the same catastrophe that struck Earth. It happened around 3.4 billion years ago. An asteroid collision might have caused a mega tsunami on the red planet, similar to the one that caused the Chicxulub impact on Earth. Scientists have identified an impact crater on Mars that was probably left by a comet or asteroid collision with the surface of the planet. Most likely, the space body landed in an ocean in the Martian northern lowlands, and the impact was so powerful that it caused a mega tsunami. Before the latest studies, the exact location of the impact crater wasn't verified. It was just a theory. To confirm it, a team of astronomers simulated a comet and asteroid collision in the area where they supposed the impact crater was. They even named this crater Hall. Hall is 68 miles across and lies in a region that is almost 400 feet below the supposed sea level. Anyway, the simulations formed several craters of the same size as Paul. One of the simulations claimed that these craters had been left by a 5-mile-wide asteroid that had encountered strong ground resistance. The other simulation showed that the craters had been caused by a bit smaller asteroid that met a weaker ground resistance. But according to both simulations, the impact crater was almost 70 miles in diameter, and the collisions produced mega tsunamis up to 900 miles away from the center of the impact site. The simulations also help scientists estimate the height of the tsunami. It was about 820 feet tall, almost as tall as the Eiffel Tower. The authors of the study also suggest that the Pole crater might be similar to the Chicxulub impact crater on our planet. The Chicxulub asteroid, as we now know it, is believed to come from the outer reaches of the solar system. This space body was at least 6 miles across. It crashed into the shallow seawaters near the Yucatan Peninsula. This splashdown was so powerful that it left its signature on the entire face of the planet. In 2021, researchers found out that the collision had carved mega ripples into Earth's crust in the region of modern-day central Louisiana. An even newer study suggests that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists remodeled the events of the first 10 minutes after the impact, and the model showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. That's like 2 Burj Khalifas, which is the tallest construction in the world, stacked one on top of the other. And of course, all that empty space didn't stay empty for long. The ocean gushed back to fill the crater. But in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, tsunami waves that were more than 33 feet tall traveled around the world at a speed of 3 feet per second, lashing at all coastlines on their way. Imagine a 3-story building rushing up to you. No wonder the largest and fastest moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall, which is taller than the Statue of Liberty, and moved at a speed 10 times greater than more distant tsunami waves. But back to the Red Planet. Some experts think that not 1 but 2 mega tsunamis could happen on Mars. They could be triggered by a pair of meteor impacts that were several millions of years apart. Between these 2 collisions, Mars went through a period of climate changes. As a result, liquid water on its surface turned into ice. In other words, the first asteroid impact most likely produced waves composed of liquid water, and the second tsunami was probably formed by rounded chunks of ice water. By the way, the largest asteroid to have ever crashed into Earth might not actually be the one that ended dinosaurs. A much more catastrophic collision likely happened about 3.5 billion years ago. New evidence scientists found in northwestern Australia suggests that the asteroid I'm talking about was 12 to 18 miles across. It struck Earth at an immense speed, releasing an unimaginable amount of energy. Now, this made me think, what if something like that happened these days? More than 30,000 objects that are circling Earth these days could potentially crash into our planet. NASA considers around 1,500 of them to be potentially hazardous. These space rocks are the remains left after the solar system was formed some 4.6 billion years ago. For example, in 2004, astronomers discovered a huge asteroid nearing Earth. The first observation showed that the chance of the space rock hitting our planet was less than 3%. The asteroid was named Apophis. It's more than 1,200 feet across and weighs about 20 million tons. It's supposed to streak across the sky on April 13, 2029. Apophis will pass at a distance of 19,000 miles away from Earth's surface. But even though this space rock might miss our planet in 2029, it doesn't mean it won't return 15 years later in 2036. If such an object hits our planet, the consequences will be unpredictable. They can vary from shattered glass and broken windows to most life forms getting wiped off the face of the Earth. And it'll probably affect the internet. Now that last thought is truly scary. But luckily, modern technologies are likely to help us avoid any catastrophic consequences. Experts have developed several ways to prevent a real-life disaster movie from happening. For one thing, we could use a spacecraft to knock this visitor from outer space off its course. Or it could somehow be blasted into pieces. Scientists could also slow the thing down with the help of concentrated sunlight. Or people could tug it away with a gravity tractor. That's a theoretical spacecraft that can influence objects in space without touching them. In sci-fi movies, a huge asteroid often sneaks up on Earth and turns out to be a nasty surprise to astronomers. It hurtles toward our planet at breakneck speed and gets discovered just weeks or even days before the collision. In reality, scientists are constantly watching all large objects in Earth's neighborhood. It means there would be plenty of time to do something before the inevitable happened. There are 3 kinds of missions scientists could prepare at short notice. Type 0, when a heavy spacecraft hurtles toward the intruder with one single goal: to knock it off its course. In this case, astronomers would have to rely on the already available information. The Type 1 mission would involve a scout. It would be launched first to get more close-up information about the space rock. Only after that, the main spacecraft would be launched. With more precise information, its journey would be way more productive. And if scientists chose the Type 2 mission, they would send a scout and a small spacecraft at the same time. The spacecraft would knock the asteroid a bit off its course. Then the scout would collect all the necessary information. Based on this data, the spacecraft would finish its job with a more fine-tuned second push. If none of these methods work, people could try going deep underground or even build a shelter on the ocean floor. But in this case, we'd need to find sources of energy that could help us survive for at least several decades. Plus, people would have to create a life support system that could somehow keep air and water fresh. Have we found another civilization? Is that a door to someone's home on another planet? Can we peek through the windows? After all, it was NASA's Curiosity rover that sent this image to Earth, and right now, this rover is exploring the surface of Mars. Unfortunately, astronomers were fast to disappoint us. They claimed that it was just a natural part of the Martian landscape. There are several clues that made them think it wasn't a real door. For example, it's tiny, a mere 3 feet high. But it might simply mean the Martians aren't that tall, you may object. But scientists keep insisting that what looks like a door is actually an opening in a rock created by natural forces, like winds and erosion. The thing is, if you look at the rock attentively, you may notice strata, the layers of silt that stand out because they're harder than the surrounding material. These strata dip here on the left and a bit higher on the right. They likely appeared around 4 billion years ago in a river or a wind-blown dune. Since the strata became visible, powerful Martian winds have eroded them even more, and now you can see that they disappear inside the door. And look at this. See those cracks? Yeah, those. That's how rocks weather on the red planet. This small cave probably formed when several fractures crossed the strata. A pretty large boulder might have fallen out under its own weight, and this created the door-shaped opening. Now, this theory is quite plausible, because even though the gravity on Mars isn't as strong as on Earth, it's still strong enough to do it. Besides, see that rock to the right of the opening? It has a suspiciously smooth vertical edge. It must be the culprit. It probably fell out not so long ago, and Martian winds haven't got rid of it yet. And winds on Mars can be exceptionally powerful. This planet is infamous for its intense dust storms. Sometimes they kick up so much dust that you can see it through a telescope on Earth. Such storms occur every year and cover continent-sized areas. They also last for weeks at a time. But besides these annual storms, there are even larger storms that happen much more rarely, but they're more powerful and way more intense. Those are called global dust storms because they encircle the entire planet. But even if you got caught in the most severe storm on Mars, it wouldn't be as terrible as you might think. The wind speed on the worst Martian storms reaches 60 miles an hour tops. Hurricane-force winds on our planet can be twice that speed. You should also keep in mind that the atmosphere on the red planet is 1% as dense as the atmosphere on Earth. That's why, if you decided to fly a kite on Mars, you'd need the wind to be much faster than on Earth. Otherwise, you wouldn't even be able to get the kite in the air. In other words, even though it's quite windy on Mars, it doesn't feel as intense as on our home planet. Oh, by the way, you might have noticed I keep calling Mars the red planet. Why? Look, our neighbor is covered in dust, soil, and rock that is rich in iron oxide. That's what gives the surface of the planet its trademark red hue. And look, there's the trademark. Nah, just kidding. Mars is the fourth planet from the Sun. Not so far away from the star, you might say, and still, it's a cold and deserted world. The average temperature on its surface is minus 81 degrees Fahrenheit. But if you ever visit one of its poles during the wintertime, bring a lot of warm clothing, because the temperatures are likely to drop to minus 220 degrees there. In the summer, though, you might feel very comfortable in some regions. There, the temperatures can rise to 70 degrees, not very different from what we're used to. Mars is one of the most explored space bodies in the solar system. At the moment, NASA has 2 rovers roaming the red landscapes, Curiosity and Perseverance. There's also one lander called InSight and helicopter Ingenuity, nicknamed Ginny. Perseverance is the most advanced and largest rover ever sent to another world. The journey to the red planet took 203 days, and Ginny traveled to Mars attached to the belly of Perseverance. Sounds cozy. And now, I'm going to tell you something really curious. Let's say you're a Babylonian who lived around 5,000 years ago. Babylonia was an empire in ancient Mesopotamia. Just think back to 6th grade. Anyway, your neighbor comes up to you and says, "What day is it today?" And what do you answer? "It's Mars Day." Wait, what? When the ancient Babylonians created the week, they decided to divide it into 7 parts. Each day got named after some space body, like the Moon, the Sun, Venus, and so on. Mars Day was on Tuesday. The Babylonians believed that each of these space objects influenced their lives on the day named after it. And since Mars was red in color, they associated it with aggression. That's why on Tuesdays, they had special ceremonies to avoid the influence of the unfriendly planet. Indeed, Mars might seem unfriendly to a tired traveler. Its atmosphere is very thin. Its volume is a near 1% of the atmosphere on Earth. In other words, there's 99% less air to breathe on the red planet. Mars's atmosphere is mostly made up of carbon dioxide. At such high concentrations, it's toxic for us humans. And if you were looking for some oxygen to breathe on Mars, you'd come away empty-handed. There's only 0.1% of oxygen in the air on the red planet. That's definitely not enough for you to survive there. At the moment, Mars has 2 moons, Deimos and Phobos. Astronomers think they may be asteroids once caught in the gravitational field of the planet. The moons are shaped like potatoes. That's because their mass is too little for gravity to give them a spherical form. Potatoes, eh? Maybe they should be renamed mashed and au gratin. One day, Mars will get a ring of its own. It might happen in the next 20 to 40 million years. Will Brightside be there? Stay tuned. Mars's gravitational forces will tear apart the planet's largest moon, Phobos. Hey, it really will get mashed. Some chunks of the former moon will crash into Mars, and others will break apart and create the ring around the planet. This ring might exist for at least 100 million years. The surface of Mars is cut by a huge canyon system known as Valles Marineris. Sounds like a pasta sauce. If it were on Earth, it'd stretch all the way from New York to California, over 3,000 miles. At its widest part, the largest canyon on Mars is 200 miles, and it reaches 4 miles at its deepest point. If you still have difficulties imagining the sheer size of this natural phenomenon, here you go. Valles Marineris is 10 times the size of the Grand Canyon on Earth. Now, since we're on the subject of gigantic things, let's talk about Olympus Mons. This is the largest volcano in the solar system, and it's on Mars too. It's 3 times as tall as Mount Everest on our planet, and that's the tallest mountain above sea level. And the base of Olympus Mons is as large as the state of New Mexico. Now, scientists think there could have been water on Mars in the past. What made them think so? They found lots of ancient river valley networks and lake beds on the surface of the red planet. Plus, on Mars, there are minerals and rocks that could only form in liquid water. Mars might even have experienced terrible floods 3.5 billion years ago. These days, there's still some water on the red planet, but Mars's atmosphere is too thin for this water to stay in its liquid form on the surface. Now, it only exists in the form of water ice. You can find it just under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar Ice Cap. Also, sometimes, salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. So, as a vacation spot, I think I'll pass.
You and your camera have been literally everywhere on Earth, on top of Mount Everest and at the bottom of the Mariana Trench. You've seen the Nile River, Niagara Falls, the Sahara Desert, the Grand Canyon, and a million other beautiful places. On every trip, you brought back breathtaking pictures. Your album is already as thick as an encyclopedia, and it's time to discover a whole new world of tourism. Let's head on a voyage to Mars. You're sitting in a shiny modern rocket, counting down for takeoff. It might seem like a big deal, but with modern technology, it's practically a ride on a bus. In only a couple of hours, you're on the surface. It's time to head to the first destination for any tourist on Mars, Olympus Mons. It's the size of the entire state of Arizona and is 16 miles high. That's 3 times the size of Mount Everest. And it's the highest mountain in our entire solar system. It's actually even more than a mountain. It's a giant volcano. This entire mountain was formed when streams of lava rose to the surface, flowed down the volcano's slopes, and slowly cooled. The freshest soil layers are about 2 million years old. So scientists don't rule out the possibility that this volcano will wake up one day. Hopefully, you're not close by when it erupts. And there are statues of Greek deities everywhere. There's Apollo, and there are Athena and Artemis, and here's Zeus and Neptune. In the myths, these deities lived on Mount Olympus in Greece. These aren't natural, of course. We built these monuments to attract more tourists. There are even plenty of souvenir stalls where you can buy a lightning t-shirt in honor of Zeus. You take your first picture on Mars and move on to the next exciting place. This is a complex of 12 giant volcanoes. Some of them reach almost the height of Olympus. It's like if you piled 60 Empire State Buildings on top of each other. They're so tall because gravity is much weaker on Mars than on Earth. There isn't as much force pushing down on them, so they can grow much bigger than anything you could find on Earth. You feel lighter than you've ever felt before, and you can lift objects 3 times as heavy as you could back home. It's easy to see why the volcanoes are so big when you jump and fly 9 feet into the air. These volcanoes have been erupting for almost 2 billion years. That's almost half the age of our home planet. That's another reason they've gotten so tall. Click! The photo is ready, and you get on the rover to explore the next landmark, Valles Marineris. This is the largest canyon in the world. It's longer than the distance from New York to Miami, and it's 4 times bigger than the Grand Canyon here on Earth. We don't know exactly how it came to be, but the most popular theory suggests that it was all because of the lava, which pushed the crust upward as it moved underground. Over time, these valleys grew into the enormous canyon of Valles Marineris. The next stop is Cydonia. The cool thing about this place is the giant rock with a human face. In 1976, we saw photos from the surface of Mars and could clearly recognize a human head here. People immediately came up with 1,000 theories as to how it could have appeared here. The fun theorizing and speculation came to an end, though, when new photos were taken in 2011. These clearer pictures showed that the eyes, nose, and mouth were just shadows that couldn't be picked out in the original low-quality image. In fact, it's just a hill, a lot less exciting up close. Wear a warm jacket to view the next landmark spot. This is the North Pole. Make sure you keep a tight hold of your camera too. It's pretty windy out here. That ice that you see is carbon dioxide, which looks like that because of the extremely low temperatures. It can get cold here at negative 226 degrees Fahrenheit. This cold place and the North Pole are responsible for the strong winds all over the planet. And there are even geysers at the South Pole. In spring, when it gets warmer, jets of carbon dioxide rush to the surface, taking dust and sand with them. Quick, get it on your camera. Various studies say that there is an underground lake as wide as Delaware Bay, 1 mile beneath a thick layer of ice. Moving on to Gale Crater. This is where the Curiosity rover landed in 2012. Oh, and here's its replica. This little guy has been studying the surface of Mars for years, and has found signs of evaporated water. This means that Mars could have fostered life in the past. The rover also found a lot of evidence of organic molecules, as well as methane gas. It could come from microbes and other living things, but we don't know enough yet to say for sure. The existence of life on Mars hasn't been confirmed, but it's exciting to think that there could have been real Martians alive at some point. You take a selfie, like you're holding Curiosity on your arm. Great, the Mars cab is already here for you, and you're heading toward Medusae Fossae. Many people believe that this could be an alien crash site because of the strange appearance of these rocks. Of course, that's not true. Scientists suggest that volcanoes have been erupting here for years. Lava has cooled into rocks, and strong winds have given them strange shapes. This entire volcanic deposit covers an area the size of a fifth of the United States. And here's a place that has made Earth scientists nervous and even scared. Hale Crater and these lines on the slopes. Studies have shown that this place was moistening, meaning that water could flow there. But then it was determined that it was dry sand streams. Scientists fear this place may be home to alien microbes, so you probably shouldn't get too close. Another mysterious place for tourists on Mars is ghost dunes. In the ancient times of this planet, there were dunes dozens of feet high. But then, they were flooded by water or lava. Their bases are preserved, but the tops have been erased. The covered areas of these dunes can still harbor microbes. Here, they are protected from wind and solar radiation and may still be preserved. Contact with them can be dangerous for humans, so you take a photo from afar. The next spot is on Mars's satellite, Phobos. Oh, there's a pretty big crowd of people gathered here. And then you see it, Phobos monolith. It's a massive rock as tall as a 30-story building. We learned about this object from pictures taken back on Earth. The monolith casts a great shadow and has spawned many theories. For example, some claim that it was built by an ancient civilization or was left here by aliens. It might even have been a beacon. All these people came here to test the theory for themselves, but it just looks like a rock up close. One more photo, and you have to hurry to the bus that will take you to Jupiter's satellite, Io. It's only safe to be here in special capsule cars that fly over the surface. And when you see volcanoes constantly erupting, you understand why. Jupiter's gravity compresses the insides of Io. They heat up and rise to the surface, erupting in volcanoes on its surface. They eject so much material that Io completely changes its surface every few millennia. Now we turn on the hyperdrives and head out into deep space. Here, in complete darkness, is the Voyager probe. It was launched in 1977 and is still in operation. It's the first human-made object to leave our solar system's borders and is the world's most distant spacecraft. Voyager carries a golden disk with a message for extraterrestrial civilizations. This amazing disk contains pictures of Earth's landscapes, people, animals, and various sounds and music. Unfortunately, it will take many thousands of years to reach the nearest star system, so we're not very likely to hear back from any aliens anytime soon. You take selfies and move on to the next part of the tour. Here, 1,000 light years from Earth, is a black hole, the most mysterious and heaviest object in the universe. It weighs as much as the sun, but it's much smaller. It's so heavy that it attracts absolutely everything, even light. So the black hole isn't actually black. It has no color at all. You can only observe it from a very great distance because it bends time. The closer you are to it, the slower time will go. And if you want to fly just a second closer to it, weeks or even months might pass on Earth in that time. In the old tradition, you toss a coin into the black hole and continue your journey through the distant cosmos. On the way home, you have to stop by an iconic spot on the moon. Here in the Sea of Tranquility, there's an entire park near the landing site of Apollo 11. This is where the first human set foot on the surface of the moon. Neil Armstrong's first boot print is still there on the surface as proof. It was made in 1969, but even now, it looks exactly the same.
So, astronomers have just announced that they might have found signs of possible life on a planet outside our solar system. Wow! This distant world is called K2-18b, and it sits about 124 light-years away in the Leo constellation. So, what life are we talking about? Little green men? Octopus-like tentacled creatures? Well, not exactly. First things first, let's define what life is. It's what distinguishes animals and plants from inorganic matter, like the ability to grow, reproduce, and change. Now, what do we need to support life? If what comes to your mind is water, bingo! Scientists have the feeling that K2-18b might be covered in oceans, and if it's so, it can support tiny forms of life like microbes. A team of researchers from the UK and the US used the James Webb Space Telescope to look at the planet's atmosphere. They found hints of two very special chemicals. On Earth, only living things can produce those, and the living things I'm talking about are mostly tiny ocean plants called phytoplankton. So, basically, this planet might indeed host life in the form of algae. Now, of course, scientists still need more proof before getting too excited. We should keep in mind that it's possible that those chemicals were made by something we don't understand yet, not necessarily by living things. But still. K2-18b is a big boy. It's more than 8 times heavier than Earth and about 2.5 times larger. So what makes it even more interesting is that it's located in the Goldilocks zone around its star. That means it's not too hot and not too cold there, just right for the existence of liquid water, which is highly important for life as we know it. Astronomers study faraway planets like this by watching how their light changes when they pass in front of their star. This allows us to figure out what kinds of gases are in the planet's atmosphere. Back in 2013, the James Webb Space Telescope found methane and carbon dioxide in the atmosphere of the planet. These are carbon-based molecules, and it was the first time they were found on a planet in the habitable zone. Scientists also saw a weak signal of a chemical called DMS, which is mostly made by tiny ocean life here on Earth. So, the researchers pointed the telescope at the planet again a year later using a different tool that could pick up more light details. This time, they found much stronger signs of DMS and some related chemicals. But the problem is the signals aren't strong enough yet. They haven't reached something called the 5 sigma level, a parameter scientists use to confirm discoveries. Plus, even if the DMS really is there, it doesn't automatically equal the existence of life. Scientists once found DMS on a comet, which means that it can be produced without some kind of life taking part in the process. And still, the amount of DMS on K2-18b looks way higher than anything seen on Earth. That's why some astronomers are sure it's coming from something living. K2-18b has been a top pick for what scientists call a Martian planet. This term means a big, watery world with thick hydrogen atmosphere. It's not the kind of place where extraterrestrial civilizations like in movies would live. But it could be home to tiny life forms, like the microbes that once lived in Earth's oceans billions of years ago. Once again, not everyone agrees on how friendly K2-18b really is for life. Some scientists think planets like this might actually be too close to their stars to hold on to liquid water. K2-18b orbits its star every 33 days, which is pretty fast, and could mean it's too hot. That's why some experts claim that even if the planet has any water at all, it might be boiling. Or maybe it's not water, but oceans of lava. But most scientists agree on one thing: we should wait and see. With just 16 to 24 more hours of telescope time, astronomers could confirm what they've seen. This could happen in the next few years. And even if it turns out K2-18b isn't the world we're looking for, we're still getting close. With powerful telescopes like James Webb and more coming in the future, we might be able to answer whether we're alone in the universe or not. At the same time, some places in our own solar system, like Mars, Venus, or Saturn's moon Enceladus, might actually have a better shot at hosting life. Or we could keep exploring other promising worlds, like Proxima Centauri b, which is the closest exoplanet we know about. It's just 4.25 light-years away from us and orbits a small star called Proxima Centauri, right in the habitable zone. This planet is a bit bigger than Earth, which makes it a super-Earth. That's what we call exoplanets larger than ours, but much smaller than gas giants like Neptune or Jupiter. Proxima Centauri b is a fast-moving world. It needs a mere 11 days to go all the way around its star. Scientists think Proxima Centauri b might have a rocky surface, and that's a good sign for possible life. On the other hand, its star blasts it with a lot of ultraviolet radiation. It might have already destroyed the planet's atmosphere, if there was any to begin with. So there's a big question mark when it comes to this world's habitability. Then we've got TRAPPIST-1e, another promising Earth-like planet. It's one of 7 rocky planets orbiting a small, cool star called TRAPPIST-1, about 39 light-years away. Discovered in 2017, it might be one of the most promising places to look for life beyond Earth. This planet is actually a bit smaller than Earth, with a mass around 1/2 that of our planet. It completes an orbit around its star in just 6 days, which is super fast compared to Earth's 365 days. The planet's size and density suggest it has a rocky surface, and that's another key factor when we talk about habitability. Even though TRAPPIST-1e is very close to its star, the star is quite dim and cool, so the planet might still have a stable Earth-like climate. Some scientists even think it could have more water than Earth. Let's move on to Kepler 186f, located about 500 light-years away. It was the first Earth-sized planet found in a habitable zone of another star. It orbits a red dwarf, which burns cooler and lives much longer than our Sun. This means Kepler 186f could have stable conditions for billions of years, giving life plenty of time to possibly form and evolve. The planet gets only about 1/3 of the sunlight Earth receives, so it would likely be cooler but still warm enough to keep water from freezing. It also seems to be a rocky planet just like Earth, which boosts its chance of hosting life. Now, how about visiting LHS 1140b, about 40 light-years away? This planet has about 5.5 times the mass of Earth. Scientists think it's rocky and possibly has a thick atmosphere, which is a big deal. An atmosphere like that can trap heat, keep temperature stable, and protect water from escaping into space. This world orbits a quiet red dwarf star, so it's not constantly blasted by harmful flares like some other exoplanets are. Some studies even suggest LHS 1140b could be an ocean world with lots of water. So it's one of the more exciting planets we've found in our neighborhood. And finally, we have Gliese 12b. Astronomers call it Exo-Venus. It sits 40 light-years away from Earth. This world is about the size of Venus and orbits a cool red dwarf star. It needs just under 13 days to complete one orbit. The temperature on the planet is around 107 degrees, which is quite warm but still okay for life. The thing that makes Gliese 12b so interesting is that it could help us understand how Earth-sized planets around cool stars hold on to their atmospheres. That's important because an atmosphere is crucial for things like liquid water and protecting life from harmful radiation. According to some researchers, Gliese 12b is one of the best chances we have to figure out whether planets like this can stay habitable. A new super-Earth has been spotted by astronomers, and it's quite intriguing. This planet, called TOI 715b, is about 1.5 the size of Earth, which is why it's called the super-Earth. It's also relatively close to us in space terms, only 137 light-years away. For comparison, most exoplanets are hundreds of light-years away, and all the interesting stuff, like black holes and nebulas, are usually more than thousands of light-years away from us. So, could it be habitable? The habitable zone is an estimate of where a planet might have the right conditions for liquid water. This is what we call some distance from the star where the temperatures on the planet should be okay-ish and water should stay liquid on its surface. It's not super precise because it depends on a bunch of factors like the type of star, how reflective the planet is, its size, and so on. Also, just being in this zone isn't enough for water to actually be there. The planet also needs the right kind of atmosphere and a few other things. So, we invented a stricter definition in 2014, the conservative habitable zone. It's a more precise term defining the best candidates that have liquid water. Otherwise, we get too many potentially habitable planets that are not actually habitable at all. The CHZ is based on how much energy a planet gets from its star compared to Earth. If a rocky planet gets between 40 to 85%, it's considered to be in the CHZ, no matter how far away it is from its star. These planets have a higher chance of being habitable. And yes, TOI 715b is located there. This super-Earth orbits the M-type star, also called red dwarf. It's a star that's much smaller and cooler than our Sun, about a quarter of the Sun's size and mass. But if the planet is located in the habitable zone, it's actually a better option for life. Red dwarfs live much longer than our Sun, a yellow dwarf. This also means that they have more time to form little creatures on their planets. And this red dwarf really is older than our star. Our Sun is 4.6 billion years old, and this star is 6.6 billion years old, give or take a few hundred million. It doesn't have much magnetic activity, so it's not dangerous. It doesn't flare up like younger red dwarfs. These flares can be super strong and might even hurt planets by taking away their atmospheres. Although some planets around it do have thinner atmospheres, it seems like this red dwarf has already gone all out. These red dwarfs are where we're looking for planets that could support life right now. Our super-Earth is really close to its star, zooming around it in just 19 days. Since the star is small and the planet is so close, the planet passing in front of its star happens a lot and looks really clear. This makes it easy for telescopes like the James Webb to study its atmosphere without needing too much time. Now, speaking of the James Webb Space Telescope, it's bringing us into a new era of understanding distant planets beyond our solar system. Imagine being able to see what gases make up the air on a planet millions of light years away. James Webb will help us to find worlds that could support life. Right now, it's trying to figure out whether TOI 715b has an atmosphere. If it does, its atmosphere might be easier to spot compared to a planet that's drier and denser. And then we might get even more height because it would look like a good place for life. On top of all that, there might be another planet in this system, also in the habitable zone. We're not sure whether it's really there, it's just a candidate with a crazy name. But if it turns out to be real, it would be about the size of Earth. Also, it would be the smallest planet in the habitable zone ever spotted by the TESS telescope. Now, another cool thing about TOI 715b is that it cannot just have water on it, but be an entire water world. An ocean planet is a type of planet that has an ocean covering its surface or has subsurface oceans. They might not have much dry land because the water can cover everything. Sometimes the entire planet can be covered in other liquids, like lava or ammonia. When it comes to planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint there might be liquid water below. And of course, we wonder if these planets can have life, hopefully not in the form of Leviathan-like monsters. Our models show that planets with oceans might be pretty common in our galaxy. This means there could be lots of ocean worlds out there waiting to be discovered. But the most important part about TOI 715b is that it's in the so-called small planet radius gap. If we give the planets a lineup, there will be those that are bigger and smaller than Earth. But there's a sudden gap in planets that are about from 1.5 to 2 times bigger than ours. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets don't form in this size range. They actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit their stars, with stars blowing away some of their mass as they dance around it, as our Sun does with gas from comet tails. This gap holds a lot of mystery, and planets, like our new super-Earth, are clues that could help us unravel it. We aren't sure whether it exists around red dwarfs. Maybe it's a gap in how dense these planets are, rather than in their actual size. So studying our discovered planet is even more interesting. It'll help us learn more about distant stars and their planets. Now, I mentioned TESS a while back, NASA's TESS, Transiting Exoplanet Survey Satellite, has been in space for 6 years now and has been incredibly successful. NASA launched TESS because we already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth. We decided to focus TESS on finding smaller Earth-like planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back, it could mean there is a planet passing in front of it. But stars can dim for other reasons too. For example, flaring up or having dark spots on their surface, which is why we need to be careful with this data. TESS shows us the size and orbit of these planets. Then ground telescopes help determine their mass. With these 3 parameters, we can figure out what the planets are made of and if they're rocky like Earth or gassy like Jupiter. Yeah, you want to avoid Jupiter after taco night. One example of TESS's discoveries was the TOI 700 system. There, it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf, and it's even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are crazy. Another big discovery was made in the AU microscopy system. TESS discovered a planet about 4 times the size of Earth and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, including supernova, hot worlds, and so on. And as it enters its 6th year, we can only expect more exciting findings to come. So get this. Earth might be actually located near space highways that could connect us to other worlds. That's because our sun sits right in the center of a giant bubble filled with hot gas, carved out by ancient supernovae. And this bubble likely has tunnels linking us to distant galaxies. So, does it mean it's time to develop space tourism? Well, let's figure it out. Most of us think space is just planets floating around in eternal darkness. But new research hints at the possibility that it might not be really true. It turns out our whole solar system is actually sitting inside a giant bubble of hot, thin gas. And it gets even better. Scientists now think there might even be a weird cosmic tunnel or channel made of this stuff. It supposedly stretches out toward faraway stars. Astronomers spent years mapping the sky, and after they put all the data together, they found something that looks like a long pathway of hot, low-density plasma, which is basically that very thin, superhot gas. And this so-called channel reaches out from around us to distant constellations. Researchers from Germany confirmed this discovery using data from a space telescope called eRosetta. We'll talk about it a tiny bit later. Now, interestingly, scientists discovered that our solar system sits inside something called the local hot bubble a long time ago. This bubble is actually a huge area, about 1,000 light-years wide. It was created when several stars exploded in giant supernovas millions of years ago. Those explosions heated up the gas around them and basically carved out this bubble of hot, low-density space. And their shock waves created weak points in the bubble around us, eventually forming interstellar tunnels. That cosmic event was so huge that the leftover hot plasma is still floating around us today. Now, to understand this bubble better, scientists used eRosetta, which is an X-ray telescope. It scans the sky looking for soft X-ray light. That's a kind of light we can't see with our eyes. It comes from hot gas, old supernova leftovers, and other structures in space. They also compared eRosetta's new information with older data from another X-ray telescope called ROSAT. And finally, putting all this information together, they were able to make a much clearer map of what's around our solar system. Mind you, this wasn't easy. They had to divide the sky into thousands of tiny pieces and carefully measure faint signals coming from warm gas, empty pockets of dust, and other stuff floating in space. But their effort paid off. After sorting through everything, they managed to figure out the faint glow of hot plasma around us. It proved we were not just drifting through empty space. We're inside a giant burned-out bubble created by extinguished stars. But what really surprised scientists was the discovery of some kind of channel. It looked like a long tunnel in space, cutting through the hot gas around us and connecting our part of the galaxy to star systems far away. They also found signs of another channel pointing toward the Canis Major constellation. And those might not be the only ones. The data suggests there could be a whole network of such paths, branching out through space. Each one works like a hidden back road. Scientists used to guess that the space around our solar system might have little pockets or rooms carved out by old exploding stars. We could probably imagine them like caves inside outer space, but no one had the necessary tools to actually prove it. But now, thanks to that new data from the Rosetta telescope, they finally have a clear picture. The telescope showed that the space around us wasn't just empty. It's full of hot, thin gas and strange shapes, including tunnels and bubbles. This proves at least part of what older scientists predicted. We're living inside a giant bubble of hot gas, and that bubble connects to other bubbles through long, low-density channels. The new study also shows that the pressure inside our bubble is lower than scientists expected. This might mean the bubble isn't closed. It could be open in some directions, letting that hot gas flow out into other parts of space. In short, this hot bubble isn't simple at all. Parts of it might be open pathways, and other parts look blocked off. Being inside it is kind of like trying to walk through a forest. Some areas have clear trails, and others are packed with trees. And even though astronomers have mapped big chunks of the bubble and found these strange channels, there's still a lot they don't fully get. Some paths look like they're made of a bunch of connected empty pockets, and others look totally closed. To understand the whole picture, we'll need better tools and more data. Hopefully, with stronger X-ray telescopes, deeper sky scans, and better computer models, we'll finally understand the nature and structure of the bubble we're living in. We might be able to make a kind of map of those hidden channels and learn how they affect things like cosmic rays, dust, and the solar wind around us. Now, speaking of telescopes, we can't help but mention the one that helped us figure out the very existence of the bubble around us. The thing is, scientists have been trying to understand a faint glow of low-energy X-rays that seem to cover the whole sky. For many years, they weren't sure where this glow was coming from. And then, the NASA-supported DXL mission finally helped to solve the mystery. Researchers used old but reliable detectors that first flew on a rocket in the 1970s. With these instruments, they confirmed that most of this X-ray glow came from a huge area of extremely hot gas around us. It was named the local hot bubble. Back in the 1990s, another X-ray mission called ROSAT made pretty good maps of the sky, and it found something surprising. Comets gave off soft X-rays too. Later, scientists realized this happened when the solar wind, fast particles from the sun, collided with neutral atoms. This process, called charge exchange, can happen almost anywhere in space. Because of this, some scientists started to doubt whether the local hot bubble was really the main source of the X-ray glow. So, to test this, DXL launched on December 12, 2012 from New Mexico. The rocket flew high above Earth's atmosphere for about 5 minutes, giving the instruments a clear view of space. The goal was to look at a worst-case situation where lots of charge exchange might occur. Right now, our solar system is moving through a cloud of cold gas in space, known as the local interstellar cloud. That's also nicknamed the local fluff. Cute, right? Neutral hydrogen and helium atoms from this cloud move through our solar system at very high speeds. Hydrogen gets affected easily by different forces, but helium mostly follows the pull of the sun's gravity. Because of this, the helium forms a focusing cone, a region with extra helium that Earth passes through every December. This cone is the perfect place to look for charge exchange, since it holds more neutral atoms than usual. But what happens during charge exchange? The solar wind comes from the sun's corona, the star's superhot outer layer. The particles in the solar wind have lost many of their electrons. When one of these particles hits a neutral atom, it can steal one of the atom's electrons. The stolen electron briefly gives off a soft X-ray. This is how the glow is created. Now, to compare things, the researchers also looked at old ROSAT data from 1990, taken in a direction away from the helium cone, where charge exchange should be weak. By putting everything together, the scientists found that only about 40% of the soft X-rays come from inside our solar system. The rest, the majority, comes from the local hot bubble. This means the huge cloud of hot gas around us really is the main source of the X-ray glow. But let's get back to the discovery of the Space Intergalactic Tunnel. It's a valuable lesson for us that space might look calm and empty when we look up, but that's not true. Space around us actually contains dust, plasma, radiation, magnetic fields, and mysterious tunnels. All of these things mix and swirl together, making space much more complicated than a simple vacuum. For the last few decades, Earth has had an interesting coincidence. The northern and southern hemispheres have reflected almost the same exact amount of sunlight back into space, but new data from NASA shows that this symmetry is collapsing. The planet is becoming lopsided in a way we haven't measured before. Why is this happening? And will it change the weather we rely on? Well, let's talk about that. If you tear the map in half at the equator, you get two drastically different pieces. The northern hemisphere is the crowded side, having around 68% of Earth's landmass. It has massive continents of North America, Europe, and Asia, the sands of the Sahara, and the snows of the Himalayas. The southern hemisphere is the complete opposite. It is a water world. Aside from Antarctica and a slice of South America, it is almost entirely a deep, dark ocean. In fact, there's a spot in the South Pacific where you can travel for thousands of miles without hitting a single patch of dirt. This area is home to the oceanic pole of inaccessibility, better known as Point Nemo. It's so remote that if you sailed there, the nearest humans wouldn't be in Chile or New Zealand. They'd often be the astronauts on the International Space Station passing overhead. It's one of the emptiest places on Earth, surrounded by thousands of miles of open ocean. Now, when sunlight travels 93 million miles and hits Earth, two things can happen. It either bounces off the planet and escapes to space, or it gets absorbed. That's because of the phenomenon called albedo. It works exactly like your wardrobe on a scorching day. Lighter surfaces act like mirrors, bouncing the sun away to keep you cool. Darker surfaces are like sponges. They soak up that energy and turn it into heat. Now, humans have actually figured this out on a smaller scale. If you didn't know, many traditional houses on the Greek islands are painted bright white. It's like a form of ancient air conditioning. The white paint reflects the intense Mediterranean sun and helps keep the inside cool. Cities are now trying a similar trick. Places like Los Angeles have spent millions of dollars coating black asphalt streets with a special gray surface to boost the city's albedo. By making the ground a lighter color, street surfaces can cool by about 15 degrees. Now, on a much bigger scale, planetary even, ice, snow, and bright deserts act like mirrors, bouncing back the light, while oceans are the opposite. They soak up the rays and store that energy as heat. So, according to physics, the land-heavy north should reflect more sunlight. The ocean-heavy south should absorb more. Meanwhile, when looking at Earth from space, one half should look brighter than the other. So for decades, NASA has tracked Earth's energy using a system called CERES, short for Clouds and the Earth's Radiant Energy System. These satellites measure how much sunlight arrives and how much leaves. This is how we learn that Earth is cheating around the albedo rule. Now think of Earth's atmosphere as a giant planetary mixer, constantly pushing heat between the north and south to keep it from piling up in one place. According to the latest data, that mixer is starting to fall behind. When scientists looked closely at the series data, they saw a clear split forming between the hemispheres. The northern hemisphere is now holding onto more of the sun's energy than the southern hemisphere. Specifically, the north is gaining about 0.3 watts per square foot per decade more solar energy than the south. Yep, that sounds microscopic, but multiply that by every square foot of the Earth's surface, and you have a massive engine of heat that could make the weather unpredictable. Now you would expect clouds to push back by reflecting more heat to space, but the data shows that the response hasn't been strong enough, so the extra energy keeps piling up in the northern hemisphere. Now, this is a big deal because heat is what makes the weather move. Hot air rises and pushes wind and storms around the globe. If one side of the planet creates more pressure than the other, those wind patterns have to shift. So it's not just that the weather is getting hotter, it's that it physically moves to new places. You've probably heard of the geographic equator, the invisible line running around the middle of the planet. But there is another equator related to weather. It's called the thermal equator. Think of this as a giant collision zone. Imagine pointing two powerful fans at each other. Where the airstreams meet, the air often gets forced upward, building what could look like a moving wall of rain. Scientists call this zone the Intertropical Convergence Zone, or ITCZ. It marks the planet's thermal equator. Sailors had a better name and knew it as the doldrums. They knew it as a zone where winds cancel each other out. Pirates in the 1700s were terrified of it. You could get stuck there for weeks, just floating, waiting for your drinking water to run out. The system acts like a planetary thermostat. It likes to hang out where the heat is. For most of human history, it stayed right in the middle. But if this imbalance keeps growing, it could nudge the thermal equator north over time. Now, you might be thinking, so what if the rain belt shifts a few hundred miles? Well, history gives us a pretty striking example. About 6,000 years ago, this rain belt sat farther north than it does today. At the time, much of what we now call the Sahara wasn't desert at all. It supported lakes, grasslands, wildlife like hippos and giraffes, and thriving human communities. Rock art from the region even shows boats and swimming scenes. As Earth's orbit slowly changed, the rain belt migrated south. Over time, rainfall faded, lakes dried up, and the landscape transformed into the Sahara we know today. The trigger was different, but the mechanism was the same. When the planet's energy balance shifts, the thermal equator moves, and the rain moves with it. This is a huge deal because rain is incredibly important for food production. It waters the regions that grow our coffee, our chocolate, not our chocolate, yep, and the crops that billions of people eat. If that belt chases the heat and moves north, the rain goes with it. The jungles in the south could dry out, while cities in the north would get hit with floods they were never built to handle. But the air is only half the story. Down at lower elevations, the extra heat triggers a chain reaction. Remember the t-shirt analogy? Much of the northern hemisphere depends on bright snow and sea ice to reflect sunlight away. But as temperatures rise, that low-altitude ice melts. When the white surface disappears, it exposes darker ocean water or bare ground underneath. This creates what scientists call a feedback loop. As the ice melts, it reveals the darker ocean or land underneath, and that dark ground absorbs more heat, which can cause even more ice to melt. It's a cycle that could make it progressively harder for the region to cool itself down naturally. Meanwhile, the oceans take their time responding. Global currents act like a giant conveyor belt, moving warm water around the globe to balance energy. But this system is delicate. It only works when the water's temperature and saltiness are just right. When the North hoards too much heat, it throws the currents off. And if the belt slows or reroutes, the effects don't hit overnight. They unfold gradually over decades or even centuries. But finally, is this just a temporary glitch? Or is the Earth settling into a brand new pattern? Right now, scientists can't tell for sure. Maybe the clouds will finally show up and fix the balance. Maybe the oceans will move the heat around and save the day. But if the North keeps gaining an energy advantage, the weather maps we rely on might change for decades or centuries. If that's the case, many places will have to rethink their daily life. Those not used to rain would suddenly feel cheated, while the value of raincoats, umbrellas, and white t-shirts skyrockets. So, how do you feel about cooking? Nah, pasta and burgers are overrated. How about something more exotic, or rather, more cosmic? So, the recipe is simple. Take a team of enthusiastic astronomers and add some old images from the James Webb Space Telescope. Stir really well, and you'll get a shocking number of tiny asteroids in the asteroid belt between Mars and Jupiter. Yummy! The highlight of this dish is the direction in which some of the asteroids are moving, because in their way, there's our poor planet. Are we doomed just because you decided to cook? Now, the asteroids I'm talking about are much smaller than the massive space rock that wiped out the dinosaurs, but they can still cause considerable damage. They range in size from as small as a bus to as big as a stadium. But even those small ones pack quite a punch. Let's look at a recent dramatic example. It happened on February 15, 2013. A small asteroid just tens of feet wide exploded in an airburst over Chelyabinsk in Siberia, releasing an insane amount of energy. Many people witnessed and recorded the event, and it gave scientists vital clues. New computer models helped scientists reconstruct the size, speed, and impact of the Chelyabinsk meteor. It was likely an asteroid, about the size of a 5-story building, exploding from 15 to 18 miles above Earth's surface with an enormous, incomparable force. The blast shattered 1 million windows and hurt over 1,000 people. Fortunately, it wasn't powerful enough to cause too much damage, but it gave us an idea about how dangerous an airburst can be. Now, an airburst occurs when an object explodes high in the atmosphere, never striking the ground, but releasing enough energy to devastate the area. But back to the small asteroids. The most dangerous thing about them is that they hit the Earth far more often than the larger ones, about 10,000 times more frequently. To make matters worse, their small size makes them harder to detect in advance, leaving little time for preparation if one is heading towards Earth. Now, let's travel back in time. Uh-oh, dinosaurs, too far back. Ah, there we go. A team of astronomers is working on a special method to find small asteroids in telescope images that were originally taken to study distant stars. Using this method, they've looked through thousands of JWST images of a star system called TRAPPIST-1. It's located 40 light-years away and is one of the most studied systems outside our solar system. Now, while analyzing these images, they discovered 138 new asteroids in the main asteroid belt, plus 8 they already knew about. And guess what? Among the newly found asteroids, 6 seem to have been pushed into paths that could bring them closer to Earth. Who did it? Well, probably nearby planets. Are they holding a grudge against Earth? Interestingly, scientists thought they'd find just a few new asteroids, but the number was much higher than they expected. Yet, it's no wonder. Right now, they're exploring a part of space they didn't know much about before. Now, let's talk about the hero of the day, the James Webb Space Telescope. It's especially good at finding small asteroids because it can detect their heat. These asteroids give off infrared radiation, which is much easier to see than the faint sunlight that reflects off their surfaces. This technology allowed scientists to spot the smallest asteroids ever seen in the main asteroid belt. The asteroids they found are pieces left over from collisions between bigger space rocks. Finding them helps astronomers understand the history of the asteroid belt and improve methods for tracking small asteroids that could threaten Earth. The researchers are planning to use James Webb to observe other star systems for at least 500 hours. They expect this work to uncover thousands more small asteroids in the solar system. Other advanced telescopes, like the Vera C. Rubin Observatory in Chile, will also help. Starting in 2025, this observatory will use the world's largest digital camera to photograph the southern sky every night for at least 10 years. Each image will cover a huge area of the sky, about 40 times the size of the full moon. The observatory might find up to 2.5 million asteroids in just 6 months, almost doubling the number we know about. Recently, NASA has identified 2 small asteroids. They were supposed to pass near Earth on December 16, 2024. Luckily, neither posed any danger to our planet. The first asteroid was 71 feet wide, about the size of a large airplane, and was traveling at 10,800 miles per hour. The second asteroid was slightly smaller, 56 feet wide, but it traveled faster at 14,700 miles per hour. But hey, even though this time the danger is past, who knows what the future will bring? It may sound weird these days, but astronomers didn't really care much about small asteroids for a rather long time. They thought of them as just random space debris that got in the way of observing stars. Some even called them sky parasites. But now, the way we see these little space rocks has completely changed. You see, until recently, we could only spot really big asteroids, those over a mile wide. The smaller ones just blended into the background noise in telescope images. But then, a clever trick appeared where multiple images of the same part of the sky were combined, making those faint small objects finally stand out. The data from certain telescopes, along with the James Webb Space Telescope, helps us improve planetary defense. But there's more to it than just protecting our planet. Studying these small asteroids also teaches us about how the solar system evolved. There are so many of them because they're fragments from collisions between bigger space rocks. One researcher has said this is like looking at old data in a new way. These small asteroids, which people used to think of as space junk, are crucial for understanding our solar system and even preparing for whatever the future holds. Among those hundreds of millions of rocks orbiting the Sun in the asteroid belt between Mars and Jupiter, some are especially worrisome. They come close enough to Earth for it to be quite concerning. NASA classifies asteroids that orbit within 30 million miles of our planet as near-Earth objects, and those could pose a serious threat if they were to collide with our planet. Right now, NASA is closely monitoring an asteroid named Bennu. This is a fairly large space rock, measuring about 1,600 feet across. It could, potentially, crash into Earth in 159 years. First, the astronauts spotted it in 1999. So currently, experts believe that there's a small chance Bennu could drift into Earth's orbit and collide with our planet by September 24, 2182. Would it be bad? Well, to put it in perspective, Bennu is taller than the Empire State Building. If it hit Earth, it would generate 1,200 megatons of energy, an amount so massive that nothing on Earth could generate that. NASA scientists are particularly concerned about a tiny chance that Bennu could pass through a gravitational keyhole during a flyby in the 22nd century. This keyhole is a region in space that could set the asteroid on a path that brings it directly to Earth. Now, Bennu flies by Earth every 6 years and has had 3 close encounters with us in 1999, 2005, and 2011. Right now, scientists estimate that the chance of Bennu hitting Earth by 2182 is about 1 in 2,700, more than 5 times greater than the chance of being struck by lightning. Although the chances of Bennu colliding with Earth are very low right now, this space rock is still classified as a potentially hazardous asteroid because it might come as close as 4.65 million miles to Earth. Now, this asteroid is another space rock that we need to keep an eye on. It's a near-Earth object about 1,100 feet across, and it was discovered in 2004. Initially, it was considered one of the most dangerous asteroids ever detected. Apophis quickly gained attention because experts believed it could pose a serious threat to Earth because of its close approach to our planet in 2029. However, after further study of its orbit, astronomers determined that there was no risk of a collision for at least a century. Well, we can all breathe easier now, can't we?
Look at this comet! Recently, it's erupted 4 times in less than 48 hours and has become nearly 300 times brighter than normal. This is the most powerful set of eruptions the comet has had in over 3 years. Should we worry here on Earth? Well, I wouldn't say scientists are worried. They're super excited. First, let me give you a little background. 29P is what astronomers call a Centaur comet. Those are icy objects that orbit the Sun in the space between Jupiter and Neptune. What's interesting about centaurs is that they're kind of like cosmic hybrids because they're moving from one kind of space body to another. They start their life as far-out objects in a lifeless, freezing cold zone beyond Neptune. But then, over a few million years, they move inward toward the Sun because the planets of the solar system affect them with their gravity. Eventually, they turn into short-period comets. This term means they can pass close to the Sun and then slingshot back out into those icy regions. Centaurs, and their name indeed comes from a hybrid half-horse, half-human creature popular in Greek mythology, are especially interesting because they're basically leftovers from the formation of our solar system, kind of like cosmic fossils. Since they've been hanging out in the frigid outer solar system for so long, they've kept a lot of the volatile materials that were present when the solar system was first forming. This makes them a valuable clue in understanding how our solar system evolved. That's what makes scientists so enthusiastic. Now, about 29P itself. This thing is huge for a comet. It's about 37 miles across, which is almost 3 times the length of Manhattan. Now, worry not, it's too far away to cause us any harm. While it's one of up to 1,000 known centaurs, 29P is also in a rarer group of comets called cryovolcanic comets. Those are a fascinating class of space objects that have unique geological activity. The thing is, cryovolcanic comets not only contain a unique mix of ice, dust, and rock, but also feature cryovolcanoes, aka cold volcanoes. They erupt with volatile materials like water, ammonia, or methane instead of molten rock. As for regular comets, when they approach the Sun, the heat from the star evaporates their gases, leading to the emissions of dust and tiny particles, electrons, and ions. These materials create those magnificent trails. These eruptions are incredibly spectacular and make the comet appear a lot brighter since the cloud of cryomagma reflects the Sun's light. The cloud that forms around the comet is called the coma, and it can grow so large and bright that it makes the comet look like a fuzzy ball of light. If you've ever observed a comet, the coma is the halo you see around it. Such eruptions are pretty unpredictable. While most cryovolcanic comets follow elliptical orbits that take them far out into the solar system, 29P is on a more circular orbit, staying around the same distance from the Sun as Jupiter. You'd think that this would mean its eruptions would be more regular, but that's not the case at all. In fact, 29P erupts in a completely random and unpredictable way, and scientists are still trying to figure out why. The latest outbursts started on November 2nd, 2024, when 29P erupted for the first time in almost 2 years. This was followed by 3 more large eruptions in less than 48 hours, which really got the attention of astronomers at the British Astronomical Association. They'd been tracking 29P for a while, and they reported that the eruptions sent out a cloud of debris reflecting about 289 times more light than the comet's nucleus, which is a huge increase in brightness. Astronomers are expecting that the coma, which is growing after each eruption, could take on an unusual shape. The multiple outbursts might cause the coma to expand in a weird, irregular way. This is especially interesting because 29P hasn't had a major eruption like this since November 2022. Then it threw out over 1 million tons of debris. The last time it had a massive outburst was in September 2021, when the comet had multiple eruptions in quick succession. In addition to the confusion about its eruptions, 29P is pretty different from most other comets. Most comets have elliptical orbits that take them far out into the solar system. They spend decades, centuries, or even thousands of years far from the Sun, only to erupt when they get close. But 29P doesn't do that. No, it orbits the Sun once every 15 years and stays at about the same distance as Jupiter. This strange behavior makes astronomers even more eager to figure out what's going on with it. Another cool thing about 29P is that it doesn't ever get close enough to the Sun to grow a tail like other famous comets, such as the once-in-a-century comet, Tsuchinseng Atlas, which has recently made headlines. It passed the closest to Earth in 80,000 years. NASA's James Webb Space Telescope has been keeping an eye on 29P, helping solve some of the mysteries about the comet. And it has recently made another groundbreaking discovery. It has detected jets of CO2, good old carbon dioxide, coming from the comet. This was the first ever detection of CO2 jets on this particular comet. Webb has also discovered a jet of carbon monoxide coming from the comet. It can tell us a lot about the composition of the comet and its outbursts. What's especially interesting is that the jets seem to come from different parts of 29P's nucleus. Even though Webb can't actually figure out the nucleus itself because it's too small to see in detail, the jets coming from different locations on the comet's surface suggest that the nucleus may be made up of multiple objects. These objects might have different compositions, and it's possible that the nucleus is more of a composite body made up of smaller chunks that came together over time. Strangely, astronomers haven't detected any water vapor in the comet's atmosphere. That's unusual because the atmospheres of most comets often contain water. Our comet might lack water vapor due to the extremely cold temperatures on its surface. It could prevent water from evaporating or vaporizing. 29P isn't the only thing that Webb is studying. The telescope has also been making some big discoveries about galaxies far, far away. For example, Webb has recently spotted a galaxy with a pretty complicated name which appeared about 1 billion years after the Big Bang. What's super weird about this galaxy is that the gas in it is shining brighter than the stars, which is really rare. This could be a missing link phase in the evolution of galaxies, something that could help astronomers understand how galaxies transitioned from the very first stars, called population 3 stars, to the types of galaxies we see today. The stars in this galaxy are much hotter than we see in modern galaxies in local universe, around 144,000 degrees Fahrenheit, compared to the typical 72,000 to 90,000 degree Fahrenheit of stars today. This could mean that the galaxy is in the middle of a super brief but intense phase of star formation, where huge, hot stars are popping up in a dense gas cloud. And this gas cloud is glowing so brightly because it's being hit with tons of light from these stars. The research team behind this discovery says that although the galaxy doesn't have population 3 stars, because the data shows it has too much chemical complexity, it still could be a guide for understanding how galaxies evolved, from the first stars to the galaxies we're familiar with today. There are still so many questions about this galaxy. Is it a rare phase? Or is it something that happens often in the early stages of galaxy formation? Astronomers are hoping to study more galaxies like this one to figure it out. About a year back, something wild happened on Mars. Its magnetic shield and air around it expanded to about 3 times the usual size. Earth has experienced this ballooning before too. In 1999, it caused our magnetosphere to expand up to 100 times its usual size. And scientists are saying that Earth might experience it again soon, but on an even larger scale. The consequences of that could be catastrophic. Let's see why it happens and what might happen to us if that repeats. NASA's MAVEN orbiter has been orbiting Mars since 2014. It's the only spacecraft we have that keeps track of both the Sun and Mars. In 2022, on December 26th, it witnessed a fascinating show on the red planet. Mars's atmosphere and magnetic shield suddenly stretched out by thousands of miles. According to scientists, it's a unique, unbelievably dramatic event and Maven was there to catch it all. Scientists tried to uncover this mystery. Digging into the event, they discovered something incredible. It turns out this air show was linked to the solar winds. Solar wind is the stream of particles coming from the sun. It's a constant flow of protons and electrons from our star's outer atmosphere. Moving super fast, up to 500 miles per second, these charged particles travel through the solar system in a plasma state. Mars, like all other planets in our solar system, is always dealing with solar wind. Think of it like a breeze from the sun. This wind pushes on Mars's magnetic shield, called magnetosphere, and is part of why Mars loses some of its atmosphere into space. Researchers found out that the weird expansion on Mars happened because there was a rare void in it. Faster solar wind caught up with slower solar wind, making them squeeze together. This created a gap in part of Mars's atmosphere because some solar wind was missing. This unusual situation caused Mars's magnetosphere to expand so rapidly. The Sun goes through a cycle about every 11 years. It jumps from low activity or solar minimum to high activity or solar maximum. Then it jumps back. We noticed this way back in the 18th century, and we're currently on the 25th cycle. It's all because of the Sun's magnetic field. During solar minimum, the magnetic field is strong and organized, but over time it weakens. Suddenly, solar activity jumps up. This creates solar winds, the Sun spewing jets of particles on the planets, including our Earth. In 1999, the solar wind nearly disappeared for 3 days. It will probably repeat again now. This time around, scientists believe it might hit us sooner and harder than expected. The Sun becomes quite lively, emitting fiery plasma, developing large dark spots, and releasing powerful radiation. And unfortunately, the upcoming solar maximum kind of caught us off guard. The storm was predicted for 2025, so scientists aren't very prepared. The number of sunspots observed has been way higher than anticipated. The Sun hit an 8-year sunspot peak in 2022, and then showed more than double the expected sunspots in 2023. It's not just them. Many solar flares have also been on the rise. In March, the geomagnetic storm lit up the skies with vibrant auroras across 30 U.S. states. It was the strongest storm in over 6 years. Many rare solar events have become more common recently. For example, a gigantic plasma waterfall, a polar vortex swirling around the Sun's North Pole for hours, and a 3-day solar tornado towering over 14 Earths. Because of all that, Earth faces some risks. Solar storms could hit our planet. It can mess with communications, damage power systems, and cause blackouts, and even pose threats to living beings. They can ionize Earth's atmosphere. This would mess with radio signals and GPS systems. Major disasters like earthquakes or tsunamis combined with such blackouts could lead to catastrophic outcomes. Additionally, strong solar storms may generate electrical currents that can damage infrastructure, including power grids and rail lines. Airplane passengers might experience higher radiation levels during solar storms. It's hard to tell what that would mean for their health. However, astronauts on spacecraft such as the International Space Station could face more significant risks. Future space missions will have to take solar cycles into account. We're not the only creatures in danger. These storms can disrupt the migration patterns of animals like gray whales, sea turtles, and birds. All these poor animals rely on Earth's magnetic field to understand what's going on. And as a cherry on top, there's a risk of satellite collisions. Commercial space companies are focused on launching satellites quickly rather than safely. Because of that, they often overlook the impact of space weather. During solar storms, the ionized upper atmosphere increases drag on Earth-orbiting satellites. If something goes wrong, satellites can be forced out of orbit and collide with us. The scariest solar storm that has ever happened to us was the Carrington event. In 1859, Earth experienced the most intense geomagnetic storm ever recorded. The sky lit up with vibrant auroras. They were visible from the North and South Poles to places like Cuba and Japan. The display was so bright in the United States that gold miners woke up thinking it was morning. It was caused by a massive solar flare. The auroras were breathtaking, but the impact was more than visual. It disrupted telegraph systems across Europe and North America. Telegraph pylons threw sparks, operators got electric shocks, and conversations were conducted using the auroral current instead of batteries. Similar storms occurred at least 3 times throughout history, with the same awful consequences. Scientists estimate the cost of such an event today could range from $600 billion to $2.6 trillion in the US alone. Researchers continue to study historical events and ice core data to understand and prepare for the potential impacts of future solar storms. The sun's behavior is very unpredictable, but this just shows that we need to study it in greater depth. The chance that this new coming storm will be the same as a superstorm like the Carrington event is low. Besides, if we spend this time preparing, it might go unnoticed. Preparation usually involves adjusting satellite trajectories, grounding planes, and identifying vulnerable infrastructure. Meanwhile, we keep exploring Mars. Its atmosphere is different from ours. Our atmosphere has breathable air, mostly consisting of nitrogen, oxygen, and a lot of other gases. Meanwhile, Mars has incredibly high CO2 levels. If on Earth carbon dioxide doesn't even reach 1%, on Mars, it makes up about 90% of its atmosphere. Also, Earth's atmosphere is over 100 times denser than the one on Mars. Even though Mars is about half the size of Earth, its atmosphere is like a feather compared to our air. A long time ago, Mars could have been kind of Earth-like. We know that it definitely had water, and perhaps there were even some plants. If we added water on Mars now, plants could have grown up there. A long time ago, Mars was experiencing some serious volcanism, suggesting it had a thick atmosphere and maybe even a giant ocean. We're not sure what happened to them, but there are some theories. For example, Mars has a magnetic field, but it's very weak, so solar winds could have stripped away its atmosphere. In the end, it became the chilly, dusty red planet we know today. NASA's Perseverance rover celebrated its 1,000th day on the red planet with some amazing discoveries. The rover cruised through an ancient Martian river and lake system. It gathered 23 precious samples along the way. All of these samples will help us to unlock Mars's history and geological mysteries. Extreme events and conditions are horrifying, but great in a way that they help us to learn more about our solar system. Luckily, MAVEN was designed to be sturdy and prepared even for intense solar storms. So now we can find out more about Mars when it's stripped of its protectiveness. Solar eclipses are amazing to witness because the moon and the sun seem to overlap perfectly in our sky, even though the sun is way bigger, about 400 times. The trick is, the moon is also about 400 times closer to our planet, so they end up looking the same size to us. Sadly, at some point during our planet's history, solar eclipses won't happen anymore. You see, the moon is actually drifting away from Earth, sliding away about 1.5 inches every year. Because of this movement, the moon will no longer completely block out the sun. Experts at NASA went on to calculate when the last solar eclipse will happen. They say it's still going to take about 600 million years, so it's safe to say none of us will be here to see it. Speaking of things we won't see in our lifetime, we might need to add stars blowing up to that list. We know what stars look like when they fade away because of telescopes, but we've never seen one with the naked eye popping up above us. Betelgeuse might not sound like a familiar name, but know that it's a red supergiant star located about 1,000 light-years from us. What's special about it is that it might explode and put on a spectacle that's never been seen from down here on Earth. This star has always been a bit of a mystery in terms of when it's gonna pop. What we do know is that Betelgeuse is in the late stages of core carbon burning. And this carbon burning phase typically lasts around 1,000 years. Chances are we won't be seeing any stars collapsing anytime soon. But since this event will most likely be harmless for our planet, it's something exciting for future generations to look forward to. Also, if you're curious to spot Betelgeuse in the night sky, it's usually visible in January and February evenings, and by early August, you can catch it before sunrise. It's got this unique muted orange-red hue, perfect for showing skeptics that stars do indeed come in colors. Our planet will also suffer a lot of changes in the future. If we could travel some millions of years ahead, we might not recognize our planet's maps at all. Currently, Earth has 7 continents, but it hasn't always been that way, and it will most likely change in the future too. About 310 million years ago, Earth had this megacontinent called Pangaea. Around 180 million years ago, it started to break apart. Now, scientists think that in the next 200 or so million years, we might see another large continent forming. In fact, we might be right in the middle of this whole supercontinent formation. There are 4 main scenarios of how this new land could come to be, each with its own twist. They all link back to how Pangaea split up and how our continents are still shuffling. Our day, the 24-hour cycle we live by, is slowly stretching out too. This sneaky, gradual change will eventually lead to days that are 25 hours long. And here's why it's happening. Earth's rotation, that spinning we do each day, is getting a bit slower each year, and it's all thanks to the moon. That's because our satellite is sort of stealing some of Earth's energy. We know this is happening because of a cool gadget called the Laser Ranging Retroreflector. It shoots laser beams up at the moon, and when those beams bounce back to Earth, it takes a tiny bit longer for them to return. This little delay is a clue that our days are stretching. So, how much longer until we get 1 extra hour each day to finish up our to-do lists? Well, experts over at NASA did some calculations. Over the last century, our days got about 1.4 milliseconds longer. And if we zoom out and look past the 2,000 years, using historical records of solar eclipses, our day has stretched by an average of 2.5 milliseconds every century. Tedious calculations aside, we'll need about 50,000 years for a single extra second to be added to our day. That means it will take 180 million years for a day here on Earth to have 25 hours. That is, of course, if nothing else happens to our planet's rotation in the meantime. The Milky Way and one of its closest neighbors, Andromeda, are planning to merge somewhere in the future too. We won't be here to experience this interaction, but it probably won't feel like much of a change from down here on Earth. Galaxies colliding may seem a bit unusual, especially since we know the universe is expanding. If galaxies are moving further and further apart, how come they still get to meet with each other? Well, galaxies that are close don't just float around. They each have an effect on the other, thanks to gravity. That's the reason why the Milky Way and Andromeda are moving closer at about 186 miles per second. If we do the math, it means their collision won't happen for another 4.5 billion years, and chances are they're going to gently pass through each other, without visible changes being felt from within our solar system. There will come a time in the distant future when Saturn's stunning icy rings won't be here anymore either, at least according to some new research. NASA's Cassini mission, which spent its time orbiting Saturn between 2004 and 2017, gathered some new information about these rings and when they might disappear. You see, scientists have been debating for a while how old Saturn's rings are. Some thought they must be pretty young because they're still so bright and icy. They figured that over billions of years, they should have been worn down and darkened by all the space objects crashing into them. In fact, it's possible that these rings were still taking shape when the dinosaurs were roaming the Earth. When foreign space objects sneak into the rings, they shove material from the innermost circle towards Saturn at a pretty fast pace. As a result, Cassini saw the rings losing tons of mass every second. That means these rings aren't going to be visible for too much longer, in cosmic terms at least. They're estimated to last maybe a few 100 million years at most. We might also miss this next cosmic event, but barely. That's because according to some estimations, it might happen in just 100 years. The Earth's magnetic field might collapse, flipping its north and south poles. Researchers claim that for the past 3,000 years, our planet's magnetic field has been on a steady decline. And if this trend continues, we might hit a critical point in less than 1,000 years. For the planet's poles to switch, the magnetic field needs to weaken by about 90%, and this can take thousands of years. During this vulnerable phase, our planet loses its protective magnetic shield, letting in more cosmic rays from space. The last time this pole flip happened was almost 800,000 years ago. Problem is, we're currently in one of those riskiest phases. The field's getting weaker, but there's a chance it might regain its strength. At this rate of its decline, though, it could nosedive to nearly zero in just a few centuries or a millennium. And we're already witnessing the effects of our weakening magnetic field on our satellites. In the vast expanse of the Atlantic Ocean between South America and Africa, there's a region where Earth's magnetic field is 3 times weaker than at the poles. Scientists call it the South Atlantic Anomaly. Satellites passing through this zone consistently face electronic problems. No one knows why this weak field region appeared in the first place, and predicting its future moves has been pretty inconclusive. One theory is that a massive swirling whirlpool in Earth's liquid metal outer core might be responsible, pushing the magnetic field away from the South Atlantic. Another thought is that the magnetic field in this region is pointing in the wrong direction, like a mini pole flip.
Most moons in our solar system look kinda similar, cold, gray, and covered in craters. But then there's Jupiter's natural satellite, Io, the angriest, most volcanically active moon in the entire solar system. It looks like a moldy pizza, smells like rotten eggs, and is currently exploding. While its neighbors are frozen and maybe hiding life, Io is blasting volcanic plumes 200 miles into space. Jupiter is truly giant. You could fit about 1,300 Earths inside it, so it sort of makes sense that it has more mass. More mass means more gravity, so much so that it basically makes Jupiter a moon magnet. It has 95 officially recognized moons, and most are tiny captured rocks, basically space rubble that got trapped. However, only 4 of them stand out as Jupiter's VIPs, with Io being the one that orbits closest. It's a bit larger than our moon, but the vibe is the opposite. Our moon is dusty and quiet. Io looks like a toxic chemical spill, and here's why. Io is caught in a gravity trap. Jupiter yanks on it from one side, and its neighbor moons impact it too. For every 4 orbits Io makes, Europa makes 2, and Ganymede makes 1. That timing keeps Io's orbit slightly off, so the squeezing never stops. This creates tides, but not ocean tides, rock tides. On Io, the solid ground bulges up and down by as much as 330 feet every single orbit. And since Io flies around Jupiter every 42 hours, it's a never-ending cycle. All that bending creates friction deep inside. It's like bending a paperclip back and forth. Do it fast enough and the metal gets warm. Except here, it gets hot enough to melt rock into magma. And that heat has to escape, so the pressure punches through the crust in hundreds of places. Some estimates put Io at around 400 volcanoes, and they don't all behave the same. Sometimes lava crawls across the ground. Other times, Io goes full cannon and blasts an eruption cloud of gas and dust hundreds of miles in the air. Imagine if an erupting volcano on Earth could reach all the way up to the International Space Station. This can happen because Io has lower gravity and a super thin atmosphere, so there's not much to slow the blast down. Plus, in near vacuum, hot gases expand fast and shove dust and volcanic material outward in huge arcs you could spot from far away. Non-stop eruptions are also why the moon looks like a giant marble dipped in mixed paint. Sulfur frost falls like dirty snow and stains the surface yellow, red, and black. Io is also famous for its lava lakes, and the biggest celebrity is Loki Patera. a volcanic bowl of about 126 miles across. What makes it cool is how it keeps refreshing its surface. A dark crust forms, then cracks and sinks. That can trigger a wave of fresh lava that rolls across the lake like a reset button. That's why Io has no craters from previous impacts like our moon or Mars. You'd expect the volcanoes to be mountains like Fuji or Etna. On Io, a lot of them are more like giant flat pits. The real mountains look like jagged slabs, like broken glass sticking out of the ground. The biggest one, South Bosal Mons, rises about 11 miles. That's like 2 Mount Everests on top of each other. These mountains don't grow like they do on Earth. Here, mountains don't usually build slowly because tectonic plates shove together, and the crust wrinkles up like a rug. On Io, it's like repaving the same street again and again. Eventually, the buried layers crack and huge slabs pop up sideways into jagged mountains, kind of like floor tiles snapping and popping upright. So where is all this lava coming from? For a long time, people thought Io had a global magma ocean right under the crust, basically a planet-sized water balloon, but filled with lava. Jupiter and other moons squeeze that balloon a bit and lava comes out. But according to the latest findings from NASA's Juno spacecraft that orbits Jupiter, that's not what's happening. On close flybys, Juno feels Io's gravity tug and uses that to measure how much the moon squishes. And Io doesn't squish like it has a shallow global lava ocean. The latest gravity measurements suggest the inside is mostly solid rock, but with lots of separate pockets of melted rock. It's not a balloon, it's more like a kitchen sponge, but instead of water, it has magma in different spots. That explains why the volcanoes are so chaotic. They're not all pulling from one global lava ocean. Many are likely fed by their own local magma chambers, so eruptions can pop off in different places, in different ways. All that chaos doesn't stay on Io. The colorful moon constantly leaks sulfur gases into space, and Jupiter's magnetic field scoops a lot of it up and spreads it into a glowing donut around the planet, right along Io's orbit. Scientists call it the Io plasma torus, and Io keeps refilling it at a rate of around 1 ton of material every second, like a moon-sized smoke machine that never turns off. But there's more. Io isn't just a volcano moon, it's like a giant space battery. As it races through Jupiter's enormous magnetic field, electricity builds up across it, the same way static builds up before a shock. That charge reaches around 400,000 volts, the kind of power used to move electricity across entire countries. And it drives an electric current of about 3 million amps. For scale, that current is like hundreds of thousands of home circuits running at once. That electricity doesn't stay on Io. It shoots along Jupiter's magnetic field lines in an invisible tube straight down into Jupiter's atmosphere. And where it hits, Jupiter lights up with a bright aurora spot called Io's footprint, like Io is dragging a glowing cursor across the planet. And as if the volcanoes and the lightning leash weren't enough, Io has one more trick. It loses its atmosphere once a day. Every time Io slips into Jupiter's shadow, the sunlight cuts off and the surface temperature drops. It gets so cold that the atmosphere literally freezes solid and falls to the ground as sulfur snow. For a couple of hours, the atmosphere deflates like a popped balloon. Then, Io comes back into sunlight, the frost warms up, turns back into gas, and the atmosphere refills again. It's like the moon is holding its breath behind Jupiter, then gasping back to life when the lights come on. And it's the same sulfur chemistry that paints the surface, so the moon is literally frosting and repainting itself as it goes. Studying Io is like watching a cosmic physics experiment run in real time. Juno taught us that tidal heating is messy. We used to think gravity melted a moon evenly to create a smooth layer of liquid inside. Io proves that wrong. The new data shows the interior is a sponge. Gravity melts specific pockets of rock, leaving the rest solid. This changes how we think about life on Europa and Enceladus. the icy moons that likely hide oceans under their ice. People get excited because heat from the rocky interior could power hydrothermal vents, and vents are like underwater chargers for life. But Io suggests that tidal heating might not warm the inside evenly. It might create scattered hot pockets, like a sponge with random warm spots instead of one steady heater. If that's true, vents on the seafloor might be rare and clustered. Life would not be spread across the whole ocean. It would gather around a few hot oases in a huge, dark, freezing sea. Io could also be like a mirror of Earth's past. Its lava temperature is closer to the super-hot lavas our planet likely had billions of years ago. On Earth, the surface gets recycled and overwritten, especially on the ocean floor, so the oldest footage is missing or scrambled. But by watching Io, we can get a rare real-time glimpse of the kind of super-hot volcanism Earth may have gone through early on, before the planet cooled down and long before life began. Io is incredibly fascinating. It's a world where the ground breathes fire, mountains snap up like broken tiles, and Jupiter literally plugs into an aurora. If this is what one little moon can do, just imagine what else is out there in the deep, dark space.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the sixth satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas? And where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
Jupiter has 79 known moons, and the 4 biggest of them that are particularly interesting are Galilean moons. They were named after Galileo Galilei. He discovered them in the 17th century. They have something in common, but at the same time are all very different. Europa is the smallest of the Galilean moons with a diameter of 1,860 miles. It orbits Jupiter every 3.5 days. The first images we got from there were taken in the 1970s. Its surface mostly consists of water ice. Europa has long fractures, often around a mile wide, that can extend for thousands of miles across its surface. They were probably formed as the crust pulled apart from tidal forces on the mysterious ocean beneath the surface. In 2012, scientists discovered water vapor plumes erupting close to its south pole, rising up to 125 miles. These plumes can help us find what's inside Europa without having to land there. Scientists think there could be a magnificent ocean hidden 10 to 15 miles beneath the solid surface. That ocean could be 40 to 100 miles deep. Even though it's just 1/4 of Earth's diameter, it contains twice as much water as all of our oceans together. This ocean is a potential environment for some forms of life. Scientists believe the entire ice crust is floating on that ocean. It probably makes a full rotation around Europa once every 12,000 years. In the image the Galileo spacecraft took, you can see small dark brown spots. They're 6 miles across and formed as the hot, less dense material was getting to the surface. It either pushed the crust or broke through it altogether. The surface of Europa consists of so-called chaos terrains. They're rough areas surrounded by a smoother surface. Its equator could be covered in ice spikes called penitentes that can go up to 50 feet high. We have them on Earth too, especially in dry areas at high altitudes. But none of them are as big as those on Europa. Our moon has over 5,000 big craters with a diameter of more than 15 miles. Europa's surface lacks impact craters and doesn't look like it's more than 50 million years old. This means the surface of Europa is changing and reforming all the time. This moon is icy and is one of the smoothest of any solid space objects in our solar system. Because of it, it's 5 times brighter than our moon. Europa is under a constant blast of radiation coming from Jupiter. It's so strong, we wouldn't last even a day there. Europa is 5 times further away from the center of our solar system than Earth. That means it barely gets any heat coming from the sun, so it can remain frozen since the average temperature is -250 degrees Fahrenheit at the equator and around -360 degrees Fahrenheit at the poles. About 40 years ago, the Voyager 1 spacecraft came close to the rocky moon Io and discovered that it's a volcanic champion of our solar system. Io is Jupiter's 5th innermost moon, 4.5 billion years old, nearly the same age as Jupiter itself. It's similar in size to our moon, and even has a similar density and amount of gravity. Many moons in our solar system consist of silicates and water ice, but Io is made of iron and silicate rock. You'd be able to see some beautiful auroras on Io. As this moon rotates around Jupiter, auroras change brightness all the time, but they're always there. Io is relatively close to Jupiter, almost 260,000 miles above its cloud tops. If you could come to Io and take a look at Jupiter from there, it would appear almost 40 times bigger in the sky than our moon. Stargazing there would be amazing. Io needs 42.5 hours to orbit Jupiter. Our moon needs almost a month. At some points, Io's tidal bulge can go up to 330 feet. It's similar to what we have on Earth. The gravity of our moon causes ocean tides. Io doesn't have an ocean, but the ground itself moves and goes up and down. It's like an elevator taking you to the bottom and then the top of a building with 30 stories. The gravity of Jupiter and its other big moons affect Io, so the solid ground tides on its surface are over 5 times as high as the highest ocean tides on our planet. All this makes Io so hot on the inside that some of the inner materials melt, boil, and try to escape in any way possible. Eventually, it creates a hole in the ground, which then turns into a volcano. Io is the most active body in our solar system when it comes to volcanoes. Io has more than 400 of those, with 150 of them erupting all the time. Some of them shoot their hot gas plumes 200 miles into space. It would be difficult to walk there because we're talking about a pretty intense world of floodplains of liquid rock, huge lava flows, multiple lava lakes, and giant collapsing mountains. Ganymede, the largest moon in the solar system we know of, also has the biggest water ocean. It's 26% greater than Mercury when it comes to volume, but it's less dense. This giant moon has a thick crust of water ice 90 miles deep. There might be a huge ocean of liquid water underneath. It extends 60 miles deep, which is about 10 times deeper than the deepest point in the Earth's ocean. The Voyager spacecraft also detected polar caps made of water frost there. Ganymede is half rock, half water, including tiny amounts of metals and ice. Its atmosphere is very thin and doesn't contain oxygen. This ocean most likely doesn't contain life. The Earth is a great example of how certain microbes and creatures can survive deep down without sunlight. But the ocean of Ganymede is so deep and the pressure is so strong that the water at the bottom is probably compressed back into ice. Certain forms of life in the deepest areas of our ocean survive thanks to geothermal vents that eject minerals. Since there's likely thick ice between the ocean and the core, this isn't the case with Ganymede. But the ocean there is salty, with multiple layers divided by icy sheets. If there's any chance of life, it could be in the part where the rocky core is in contact with the most internal icy layer. Beneath all that water and ice, Ganymede is the only moon in the entire solar system with a magnetic field. It's possible because this moon has a liquid core. Ganymede circles Jupiter approximately once every 7 days. Its orbit is so eccentric that at some points, it's pretty close to Jupiter. Ganymede, Io, and Europa have gravitational forces that affect each other. In the time Ganymede orbits Jupiter once, Europa makes 2 orbits, and Io makes a full circle 4 times. 1/3 of Ganymede's surface contains big dark regions, while the other 2/3 are lighter. Dark areas are older and contain more craters. Lighter areas have long ridges and grooves, about 2,300 feet high and thousands of miles long. Callisto, the 3rd biggest moon in the solar system, 3,000 miles in diameter, needs 17 Earth days to orbit Jupiter. Its atmosphere is very thin. There are many impact craters, but its ancient crust has basically been the same for more than 4 billion years. When a planet is geologically active, like the Earth, some things can erase most of the evidence from past impacts: water, volcanoes, tectonic plate movements, human activity, and weather. All this changes the surface. Callisto has experienced none of those. Scientists think this moon used to be an ocean world that eventually froze over. It was hit by meteors from time to time, but mainly remained untouched. And yet, it still has some pretty impressive craters, like Valhalla, the biggest multi-ring crater in our solar system. That's 2,500 miles in diameter. Major craters on Callisto contain more rings than those on other celestial bodies. Whatever hit the moon was big enough to have punctured the thin crust, causing water to spread on the surface. And under this thin crust, there could be either salty ocean or soft ice. The Galileo space probe detected that Jupiter's magnetic field couldn't penetrate through this moon, likely because of a layer at least 6 miles thick. That's why it's hard to explore Callisto. Moons like Europa have vents that eject water from the subsurface oceans. But to explore Callisto and discover more about its past, we'd have to use the old school way, digging through the crust. If we wanted to explore the outer parts of our solar system, Callisto would be a great spot because Jupiter's radiation doesn't reach it. So we'd be safer there than on some other inner moons.
Hey, wake up! Quick, listen to that. It's a 5-second FM signal coming from one of Jupiter's moons. You fumble for your phone and inform your colleagues. They freak out over the news and rush to the lab. You've been a scientist working with the Juno probe, exploring Jupiter for years. But this is the first time you've witnessed something so unusual. Ganymede is Jupiter's largest moon and the biggest moon in our solar system. If this space body didn't orbit around Jupiter, it would be classified as a planet. It's even bigger than Mercury and Pluto. What makes this moon stand out among others is the fact that it has its own magnetic field. The moon was born around 4.5 billion years ago. It means it's as old as Jupiter itself. This planet-sized space body takes 7 Earth days to orbit its planet. Everyone gathers at the laboratory, impatiently waiting for you to play the recording of the signal coming from space. Your colleagues get their game on, trying to figure out what the source of this mysterious sound is. Around 40% of Ganymede's surface is dark, with craters scattered around, and 60% is light-colored. There are formations that were probably caused by tectonic activity or the release of water from under the surface. Scientists managed to discover a thin layer of oxygen trapped in the moon's atmosphere. The temperatures there are super low, between -170 to -200 degrees Fahrenheit. There isn't much information about how the moon behaves or what chemical elements it hides inside. Some of your colleagues try to create the same conditions that existed when the sound was transmitted. For hours, they sit there waiting, but nothing. Maybe it was a fluke. You get to the control system and activate the Juno spacecraft. The main point of this mission is to observe Jupiter's gravity, magnetic fields, the atmosphere, and the planet's evolution. By the way, there's also some evidence that Jupiter's largest moon is evolving too. Since it has a magnetic field surrounding it, auroras pop up all the time. Those are glowing gas circling the moon's north and south poles. If life existed in such a place, it would probably be at the bottom of Ganymede's extremely salty ocean. For a long time, scientists thought that the sun was a crucial component to kickstart life. But now we know that there are organisms dwelling deep at the bottom of the oceans. Those are doing just fine without sunlight. The oceans of our planet are teeming with some of the most bizarre creatures of all shapes and sizes. Sea lilies live some 10,000 feet underwater. They got their name because they look like flowers, except they're not plants but animals. Don't be fooled by their stems and leaves. Those are body parts equipped with nerve endings to detect food around them. Goblin sharks are probably some of the most weird-looking sharks that live at the bottom of the ocean. They can grow up to 12 feet long and have a very unusual snout. Now, take a look at the anglerfish. It has a bioluminescent blob on its head to attract prey and navigate its way around the dark ocean floor. It's a natural flashlight that never needs new batteries. It's only the females that have these flashlights, though. The blobfish is another bizarre animal living down there. It lives in the Atlantic, Pacific, and Indian Oceans, 9,000 feet under the surface. Anyway, even though you asked everyone to keep the news confidential, it somehow leaks to the media and becomes a new trending topic. You get a call from a news agency. They say they want to interview you about this breakthrough that may prove life exists in outer space. The next day, you head down to the news station to talk about your discovery. You have a whole live studio audience watching your every move as you reach out to grab your glass of water. The crew scurries around doing some last-minute checkups before you're live on air. The makeup artist does some final brush-ups. The sound engineer asks you to test your mic once more. Several of the producers are sitting in the front seats. Bright lights are flooding the studio. The countdown begins. 3, 2, 1, and you're introduced. And the host asks you to explain what it was that you heard. You tell them about the Juno space probe orbiting Jupiter. After a couple of questions, the host finally brings up the most dreaded one. Might the mysterious sound be coming from another civilization? Everyone leans in, waiting for you to answer. You freeze, not knowing what to say. Even though the crushing pressure at the bottom of the ocean is 1,000 times stronger than at sea level, life still exists there. Algae, which is considered a delicacy in the ocean world, is off-menu for deep-sea creatures due to a lack of sunlight. Many of these bottom dwellers have to munch on leftovers instead. Those sink down there from the upper layers of the ocean. The freezing temperatures and the intense pressure have altered the cells of these creatures. This has made them more resilient than the average fish. Bacteria were developing their own ways of surviving. Studies show that they feed on certain gases and chemicals, like sulfur and carbon dioxide. Methane and hydrogen are released when tectonic plates move against each other, and some of these bacteria feast upon those gases too. Tardigrades, also known as water bears, are microscopic critters that can live and thrive in extreme conditions. You can find them in volcanoes, frozen glaciers, and even in the empty void of space, which means that some life forms might actually exist on Ganymede. You explain this to your audience. Then you mention that you don't have enough information to determine if it was another civilization or a natural phenomenon that produced the sound. This doesn't mean that the bottom of Ganymede's freezing oceans isn't teeming with its own bizarre and weird creatures. There might be some legendary beasts like the kraken or leviathan there, or weird glowing fish with two heads, a fish with tentacles and a large fin, giant crabs. The bacteria there might be as varied as our own. The plants, if they exist there, have to be strong enough to survive the sub-zero temperatures. The animals on Jupiter's largest moon could be as big as our blue whales or as tiny as plankton. After the interview, you head back to the lab to examine the records once more. On your way home, you see posters of yourself with captions like, "Are we not alone?" Hey, you've become a celebrity. Many people take pictures of you. You've been booked by other agencies for more interviews. Some science magazines even want to put you on the front cover as the Person of the Year. Every time you come to work, you wait for the sound to appear again. But nothing. You send a signal from the Juno probe, trying to make some sort of contact with whatever produced the sound. Nothing. That night, you pass out on your desk once more. Eureka moment wakes you up in the middle of the night. There might be something you've missed. You run the numbers again and realize that the answer was in front of you this whole time. It wasn't another civilization that produced this sound. The source was electrons. Every planet produces its own sound. It's created when charged particles from the solar wind and the planet's magnetosphere interact with one another. That's what happened on Ganymede. The electrons in its magnetic field, where the probe picked up the signal, were acting stranger than usual, and this amplified some irregular frequencies. You're embarrassed and spend the rest of your night making phone calls, telling your team the news. The agency that interviewed you releases a statement. They explain that other civilizations aren't trying to contact us. You sit back at your desk, waiting for the next big thing to happen. Europa is another of Jupiter's moons that may host life. It's made up of an iron core, a mantle, and a salty ocean, twice the volume of all the oceans on Earth. And just like Ganymede, the ocean lies under a water ice crust. Scientists claim that there might even be active volcanoes there, and some resilient bacteria may live there. With enough water, certain chemicals, and a source of energy, Europa could produce life. But it's unlikely that we'll find anything but tiny microbes. A few years ago, NASA caught a mysterious green glow on Jupiter. It was moving at breakneck speed and almost escaped detection. Could it be proof that Jupiter has secrets we've been missing for decades? And if so, how will it affect us humans on Earth? Well, the truth is, astronomers didn't just stumble across this phenomenon. They've been studying Jupiter very carefully for a long time. The reason is the Juno mission. The Juno spacecraft was launched in 2011, and it reached Jupiter in 2016. Since then, it's been orbiting the planet and collecting tons of data. Juno's job is to help us understand what Jupiter is made of, how its atmosphere works, and what's happening deep inside the planet. In 2020, one of Juno's cameras, called JunoCam, clever, captured something strange. Near Jupiter's North Pole, a bright green flash of light occurred. This light appeared to be moving very fast. Capturing fast-moving objects in space is extremely difficult. That's why this image surprised many scientists. So, What could this green glow be? The most plausible and widely accepted explanation is lightning. But lightning on Jupiter is very different from lightning on Earth. On Jupiter, lightning forms inside massive clouds made of ammonia and water. These storms are far stronger than anything we experience here, and they can produce unusual colors, including green. But what if the green glow isn't lightning at all? Why didn't we see it before? This glow could always exist, but it probably moved too fast for our cameras to catch until now. Anyway, if we spot it again, we would be able to study it more closely and figure out what's really going on. Until then, a lot of the explanations are still educated guesses. Another question is what this might mean for Earth. Scientists are sure it won't have any direct impact on our planet. But the discovery is still important. It shows that weather-like phenomena such as lightning exists on other planets, and sometimes in much more extreme forms. Like on Mars, for example. Scientists have just discovered that the planet's atmosphere crackles with static electricity. In other words, Mars has tiny lightning. Back in 2021, when a dust devil rolled over NASA's Perseverance rover, scientists expected to hear the usual stuff: sand scraping, wind rushing past. Instead, the rover picked up a faint pop. At first, it didn't make much sense, and now, researchers finally think they know what it was. That sound likely came from electricity discharging in Mars's thin air. Basically, mini lightning on Mars. It doesn't look like lightning on Earth. There are no bright flashes streaking across the sky. Mars's atmosphere is too thin for that. Instead, these are tiny sparks. Still, they count as lightning, which officially makes Mars the third planet beyond Earth known to have lightning, after Jupiter and Saturn. How did scientists find this? Well, Perseverance has a microphone called SuperCam mounted on its mast. Over 2 years, it recorded about 28 hours of Martian sound, and hidden in all that audio were 55 short bursts that matched what you would expect from small electrical discharges. The sparks were super tiny, like those little shocks you get when you touch a doorknob after walking across a carpet. Yeah. Each spark lasted only milliseconds, but 7 of them also lined up with electromagnetic interference. This is a big clue that electricity had jumped through the air near the rover. But where does this Martian lightning come from? On Earth, lightning forms inside storm clouds when ice particles collide. Now Mars doesn't have rainstorms like that. It's too cold and dry, but it does have a lot of dust. When strong winds whip dust grains around, they rub into each other and trade electric charges. Scientists use a long and complicated word to describe this phenomenon: triboelectrification. But the idea is simple. Friction builds up electricity. Once that charge grows strong enough, it releases. That release creates both sound and electromagnetic waves, the very signals Perseverance detected. These tiny sparks might sound harmless, but they matter a lot. Electrical activity can change Mars's chemistry. It may help create reactive chemicals like hydrogen peroxide and percolates, which break down organic matter. That could help explain why Mars struggles to preserve signs of ancient life. Electricity might also affect how dust moves. Charged dust lifts more easily, which could help dust storms grow and support themselves. That creates something like a feedback loop: more dust, more charge, more storms. And there's a practical side too. These sparks won't hurt astronauts directly, but they could interfere with electronics or damage sensitive equipment. Knowing when and where they happen will help engineers design future missions and future spacesuits to handle Mars's electrically active environment. Now, let's move further away from the Sun. Here's something that might change how you picture the solar system. New simulations suggest that Uranus and Neptune might not be giant balls of ice after all. They could actually be much rockier on the inside, with thin icy layers around. Researchers at the University of Zurich ran new models and found that these ice giants don't have to be ice-dominated to match what we observe. In fact, many of their simulations work just as well if these planets contained a lot more rock than expected. Based on the data we have today, Uranus and Neptune could be rock-heavy or ice-heavy. There's just not enough information to choose between the two. That's why scientists keep calling for missions that would orbit these planets and study them up close. Voyager 2 flew past Uranus in 1986 and Neptune in 1989. It grabbed a few measurements and kept going. No spacecraft has ever stayed long enough to really figure out what's happening beneath the clouds. So scientists rely on computer models built from limited clues. The classic ice giant picture still works, but it's no longer the only explanation that fits the data. Now, another astonishing discovery involves Uranus's moon, Ariel. Even though it's small, scientists now think it could have once hidden a massive underground ocean that made up more than half of its entire volume. That ocean could have been around 105 miles thick, and it might have existed as recently as 1 billion years ago. Ariel is only about 720 miles wide, roughly a third the size of Earth's moon. Because of that, scientists used to assume it couldn't hold on to heat for very long. Newer research doesn't quite agree. When Voyager 2 flew past Uranus in 1986, it sent back images showing that Ariel's surface didn't look old and frozen. Instead, the moon looked relatively young and active, with cracks, ridges, and even signs of ice volcanoes. Some of those features look surprisingly similar to what we see on moons, like Europa, Enceladus, and Triton. And those are places we already know have oceans beneath the ice. Later on, scientists also found traces of ammonia and carbon-based compounds on Ariel's surface. Those chemicals usually don't last long, unless something keeps bringing them up from below, which often means liquid water underground. Researchers built models of what the inside of Ariel might look like. In their simulations, the moon had a brittle outer crust, a softer layer underneath, a deep ocean below that, and a solid core at the center. After that, they tested how Ariel's crust would react to tidal forces, the constant stretching and squeezing caused by Uranus and nearby moons. It turns out that if Ariel's crust was less than about 19 miles thick, it would crack under a serious amount of tidal stress. One source of that stress could be an interaction with another moon, Miranda, about 1 to 2 billion years ago. That interaction slightly stretched Ariel's orbit and put enough strain on the crust to break it. In any case, it's too early to claim that Ariel still has a huge ocean today. It's small, and it loses heat easily. If any liquid water remains, it's probably much thinner and not exactly a great place to look for life. Hey, what do you say we light a giant match on Jupiter, the largest room of explosive gas in our solar system? Jupiter has methane, a gas that's famous for its bright burning. Plus, there's metallic hydrogen, which, under the planet's extreme pressures, turns into a potent fuel. However, when we try to start a fire, nothing happens. There are no expected explosions. Now why is that? And can we fix that if we really want to blow up Jupiter? Jupiter is the titan of our solar system, the biggest planet we have nearby. It's 11 times wider than us. If Earth was a nickel, Jupiter would be a basketball. It's hanging out as the fifth one from the Sun, right after Mars. It's also more than 300 times heavier than our Earth, and twice as heavy as all the other planets combined. Because of this enormous mass, it acts as a moon magnet. Jupiter has 95 known moons. The most famous of them are the Galilean satellites, Io, Europa, Ganymede, and Callisto. They were discovered by Galileo Galilei in 1610. Jupiter also has some rings. Now, they're not as fancy as Saturn's though. Just faint rings made of dust, not ice. Because of that, they don't reflect light as brightly, and we can't see them with a naked eye. Jupiter also has the shortest day in our solar system, only about 10 hours. But it takes the planet about 12 Earth years to go around the Sun one time. But the most important thing about the planet is that, unlike Earth, it's not solid. Jupiter, as well as Saturn, are the so-called gas giants, planets made mostly of gases. Gas giants are mainly composed of hydrogen and helium, the same stuff that makes up stars. Jupiter and Saturn also have a dash of other heavier elements. This doesn't mean that the entire planet is just a ball of gas. The pressures inside are so harsh that molecules can't stay in that form. Their outer layers are made of compressed molecular hydrogen. As we dive deeper, it turns into a layer of liquid metallic hydrogen. Finally, there's a potential rocky core deep down. From the outside perspective, it looks like layers of clouds in their atmospheres. Jupiter also has these stripes and swirls that look like patterns. Now, in reality, they're chilly clouds made of ammonia and water, floating in a mix of hydrogen and helium. Its famous Great Red Spot is actually a massive storm that's been raging for hundreds of years. This storm itself is bigger than our whole Earth, and it's twice as fast as the Earth's fastest possible storms. So this is the problem we encounter when we try to light a fire on Jupiter. If you somehow manage to stand on Jupiter without any solid surface, while not caring about the titanic gravity and the crazy storms, fire needs oxygen to burn, and Jupiter's atmosphere doesn't have any. No oxygen, no flames. Well, let's assume that we have a magic match that can generate its own oxygen. That should work, right? Well, unfortunately, Jupiter is so massive that you would need an insane amount of oxygen to do that, perhaps way more than the entire solar system has. You might have heard that Jupiter protects us from dangerous asteroids. It's so gravitationally strong that it attracts all the objects that could have hit Earth otherwise. In general, Jupiter experiences from 30 to 100 collisions per year. Well, these meteorites falling on Jupiter didn't cause explosions either. Even the most powerful crash on Jupiter didn't. It happened with a comet called Shoemaker-Levy 9 in 1994. The comet broke into pieces in 92, some as big as half a mile. And then, in 94, it got a little too close to Jupiter. The impact was incredibly dramatic. Over 6 days, 21 fragments hurtled into Jupiter's atmosphere at great speeds. The planet's atmosphere heated up to 53,000 degrees Fahrenheit. Like a ripple effect from a tossed rock into a pond, the impacts created colossal plumes. They reached up to 1,900 miles above Jupiter's clouds. Dark clouds of impact debris scarred Jupiter's atmosphere for months, gradually fading away in the planet's winds. Now, this impact told us a lot of interesting things about Jupiter. For example, the dark impact clouds acted as wind tracers and revealed high-altitude winds in Jupiter's stratosphere. Changes in Jupiter's aurora helped us learn more about the planet's magnetosphere. And finally, it provided insights into Jupiter's chemistry. Comet Shoemaker-Levy 9 sparked NASA's interest in addressing the risks of impacts like that on Earth. This, in turn, helped us to learn more about comets and impacts in general. Saturn, the sixth planet from the Sun and the second largest in our solar system, is also a gas giant. Like Jupiter, it's not just a plain ball of gas. Even though it's mostly made of hydrogen and helium, at Saturn's center there's a dense core of metals like iron and nickel surrounded by rock. What's interesting is that it's much lighter than Jupiter. It's only 95 times heavier than Earth. Saturn has stripes in yellow, white, reddish, orange, pink, and green. Who came up with that color palette? Winds in the upper atmosphere can reach a staggering 1,090 miles per hour, even faster than on Jupiter and unimaginable compared to Earth. They look like colorful belts covering the planet, finishing with fascinating rings. Now, these rings are made up of bits and bobs from comets, asteroids, and shattered moons. There's even a Cassini division, a gap that separates some of these ring layers. Now, what about Uranus and Neptune? They're also giants, and for a while, scientists believed that they belong to the same family as Jupiter and Saturn. However, after a while, we discovered that they belong to a different category, ice giants. Again, they're not some giant ice cubes floating in space. Instead, they're mostly made up of heavier substances like water, ammonia, and methane, which could freeze into icy layers in their atmospheres. This is what sets Uranus and Neptune apart from gas giants, despite sharing some similar traits, like awful storms. Our solar system isn't the only one that has planets like that. There are also extrasolar gas giants. categorized by their atmospheric properties from ammonia clouds to entirely cloudless. For example, there are hot Jupiters, a separate category for, well, very hot Jupiter-like planets. They're gas giants that settle too close to their stars. For example, Kelt 9b and Kepler 7b are so close to their suns that 1 year on them lasts just 18 hours. Recently, we also discovered a little hot Jupiter. This planet, called HIP 67522b, is only a few million years old. Sounds like a lot, but it's nothing on a cosmic scale. Our own moon is about 4.5 billion years old. Now, this discovery challenges the norm. Most hot Jupiters out there are a way over 1 billion years old. We're still not sure how this one formed so quickly. What's even more interesting is how these hot Jupiters end up so close to their stars in the first place. Theories abound. Some say they formed right there, despite scorching conditions. Others believe they ventured in from outer space. For example, icy materials made together in a drifting rogue planet. And when it passed around the star, it got attracted by gravity and stayed in orbit. Maybe it happened early on, when the star was wrapped in a gas and dust cocoon. Or later. Scientists will need more research to say for sure. There are also weird oddballs. No, not me. Gas dwarfs. They're also called mini-Neptunes. They're smaller versions of gas giants that have rocky cores swaddled in thick hydrogen and helium blankets. They're called after Neptunes because, after being a bit smaller than this planet, they share a lot of similar traits. Their size ranges from about 2 to 4 Earths. Usually, it's a world with a hefty atmosphere, mainly filled with hydrogen and helium, and perhaps layers of ice, rock, and even liquid oceans beneath the surface. If a planet like that didn't have much gas in its wardrobe, we'd call it an ocean planet instead. We're not sure why they exist, and they defy some scientific norms. Like hot Jupiters, these planets require more exploration.
Billions of people are staring at the sky. Their eyes reflect a fascinating picture of how the planet's atmosphere is changing. The blue sky is becoming brighter and is taking on a dark blue hue. It looks like a drop of paint spilled in a glass of water. Birds have stopped flying, animals go crazy because they feel something is happening. Lightning flashes somewhere and the sky turns fiery orange. This is an approximate visual picture of what would happen if Jupiter's gas poured onto Earth. But let's find out what physical and chemical changes would happen in our world. First, we need to understand what Jupiter is and what it consists of. The largest planet in the solar system is a massive ball of gas. About 90% of this gas is hydrogen, and the remaining 10% is helium. Of course, there are other substances too, but their amount is insignificant compared to hydrogen. If you entered Jupiter's atmosphere and jumped down, you would keep flying straight towards the planet's core for a very long time. Scientists don't know exactly what the core of Jupiter is made of. There may be something solid and gigantic. Anyway, most of the time, you would be flying through blue layers of hydrogen, closer and closer to the planet's center. But why isn't this gas spreading in different directions? All thanks to Jupiter's gravity. The mass of the planet holds this gas together. Now, let's find out what hydrogen is. It's the simplest and most common chemical element consisting of one proton and one electron. Simply put, it's a universal gas that can store and delivers various energy. 90% of all atoms in the universe are made up of hydrogen. Hydrogen is a part of a lot of stuff, like water, many biological substances, atomic energy, and many more. Therefore, to get hydrogen in its pure form, people extract it from various substances using chemical actions. Hydrogen is inside our fluids, joints, bones, and muscles. It ensures the functioning of our bodies and contributes to the existence of life on the planet. Also, hydrogen slows down the process of aging. But if our planet received a huge dose of Jupiter's hydrogen, it wouldn't make us better, younger, and stronger.
Hydrogen is only effective in combination with other substances. To benefit from it, you need complex chemical processes. But what about helium, which is also Jupiter's gas? It's lighter than air because of its low density. That's why helium-filled balloons rise up. People use this substance in medicine to treat respiratory diseases and to cool magnets and processes inside the MRI. Nothing terrible would happen if a massive amount of this gas got into our atmosphere. Our voices might become a little thinner. In any case, hydrogen would bring many more problems. Let's imagine that some cosmic force is moving Jupiter towards our planet. Then, for some reason, the core of Jupiter disappears. Hydrogen and helium begin to leak into outer space and fly to the nearest source of gravity, our Earth. The sky starts to turn a brighter blue. This happens because of the connection of water molecules with hydrogen molecules. Atmospheric pressure is increasing. Animals are going mad, and people are getting headaches. A few seconds later, the pressure disappears because hydrogen is easily ignited. Any spark can start a chain reaction. Hydrogen could burn the entirety of Earth's atmosphere, consisting of nitrogen, helium, oxygen, and other gases. All life on Earth would be erased in a matter of seconds. A tremendous amount of energy would be released. Earth's temperature would be only 2 or 3 times colder than the Sun's temperature and almost 4 times as hot as the surface of Venus. All the oceans would hiss and evaporate. Then the hot water vapor would fly away into space. Atmospheric pressure would disappear, but nobody would care about that. The planet would look like a big scorched desert. But what if people were ready for this? What if no one lit a match and people replaced all metals with plastic or wood? Unfortunately, it wouldn't help. There are millions of lightning strikes in the world every day. Any of them would ignite the atmosphere and destroy all living beings. People would have to figure out how to stop lightning strikes forever. But that would cause another problem. Lightning is necessary for our world to keep an electric balance on the planet. But anyway, this is a topic for another video. Luckily, pouring Jupiter's gases into our planet's atmosphere will never happen because Jupiter is too far away from us and its core will not disappear. But what if you flew to this planet and threw a match into its atmosphere? Nothing would happen. The match would go out the moment it leaves the spaceship. Fire burns only when it's in contact with air, and there is too little oxygen in Jupiter's atmosphere. Besides, it's contained in water molecules, and this is insufficient to create a flame. But what would happen if our planet became a gas giant like Jupiter? For this to happen, Earth must have a huge gravity. Jupiter holds all these gases because of its enormous weight. It's heavier than all the planets of the solar system combined, and 100-fold heavier than Earth. Imagine what would happen if our world's core started increasing in size and mass. If the planet got such a mass, all living things would disappear because of the enormous pressure. Earth would become the heaviest space body in the solar system, not counting the Sun. But life on the other planets wouldn't change much. Oh, but the Moon wouldn't be as lucky. The increased gravity of Earth would attract our natural satellite and tear it apart. The Moon would split into billions of parts and possibly form a belt around our planet. It would look like another Saturn. And what if Saturn used to be similar to our Earth? What if life once flourished on its surface? It could be a beautiful planet with oceans, forests, and mountains. But then something went wrong, and its core increased in mass. Its atmosphere began to grow and change the gravity of neighboring satellites. They collapsed and formed a huge belt around Saturn. And now, let's look at changes that would happen if Earth got Jupiter's gases slowly. Imagine our atmosphere filling with hydrogen gradually. In this case, new forms of life would appear on Earth's surface, like microbes and bacteria. Some of them could later develop into big forms of life. In the next thousands of years, the animal world on our planet would change beyond recognition. Perhaps we would see the appearance of new species of animals, microbes, and insects, and the disappearance of older ones. The consequences would be unpredictable. Fortunately, this won't happen. Right now, our planet has an ideal atmosphere. All life forms in this world are adapted perfectly to the amount of hydrogen that we have. By the way, there's a theory that Earth was originally the core of some gas giant. Billions of years ago, our planet could have been inside a gas giant close to the edge of the solar system. Perhaps this big guy was further away from Jupiter and Saturn. So this unknown planet traveled around the Sun and then it began to fall apart. Inside it, there was a collapse caused by the gravity of neighboring planets. The gas dissipated and our Earth came out of the cloud. Then it approached the Sun and took the orbit it follows now. And what if the same thing happens to Jupiter in a couple of billion years? For example, hundreds of giant asteroids could fly past it and destabilize the gas giant's atmosphere. Some of the asteroids would fall on the planet, provoking a strong release of energy. Jupiter would begin to fall apart and change its position in the solar system. And then, through the clouds of hydrogen, we'd see a solid core. And then it would get out of the gas cloud and approach our planet. Life would start forming there, and people would call this planet Earth 2.